Hello everyone, welcome back to Ask a Scientist Gaming, where we combine mediocre gameplay with expert level science. I'm Ken Hansen. I do light matter interactions, dyes, pigments, solar cells, sensing, whatever it might be, as long as light is driving the process, I'm interested in it. But more importantly, joining me today is Professor Josh Melko from University of North Florida. Josh, if you wouldn't mind introducing yourself.
Sure. I'm Josh Melko. I'm a physical chemist, associate professor at the University of North Florida. My lab studies ion molecule reactions in the gas phase, so applications in atmospheric chemistry, trying to figure out how fast reactions happen and what they make, to feed climate models and predictions about Earth's atmosphere and the atmosphere of Mars.
All right, equally important, what game are we playing tonight?
We are playing Kirbys Avalanche. It is a game I played a lot and got really, really obsessed with and good at during, I think, like summer camps or working at summer camps or something. So it's not the most popular game, but it's pretty straightforward and seemed like a good game to stream and be able to still talk and kind of think at the same time.
That is mildly important during this stream. All right.
Yeah, I mean, it might not work. We'll see.
That's fine. It's all yours. Take it away. We won't make you think too hard.
Yeah, I guess we'll see. It's nice to see the chat so active. Hello.
Yeah. Spider Yan, thanks for stopping by. Dr. Florida Man spotted. Assuming that's one of yours.
Yeah, OpenSet is a microscopy streamer on Twitch, actually. So, yeah, he's really, really good stream. Highly recommended if people don't know about him. Scuzzbot. Thanks for the welcome. Appreciate that.
All right, so before we dive into random questions from the audience, let's start with, not only are you a scientist and an educator, but you are also a Twitch streamer. So you got into the game early, as in one of the early academics in terms of, I think you started with office hours on Twitch. That was what, 5-6 years ago? What was the...
4 years ago about, yeah.
4 years ago? Okay. What was the inspiration behind
that? Basically, I didn't have students coming to office hours in person, and I just wanted to try to find some way to engage them. So I thought about some online office hours, and around the same time I was thinking of this, I discovered Twitch. I don't remember if it was like Bob Ross or what exactly it was, but I do know, actually. It was a fantasy football guy that I listened to a lot, started streaming on Twitch. And so I started watching him. I was like, I don't know what's going on here. I don't really understand it, but it's a really good platform for engaging an audience and keeping some active engagement, which I thought might be cooler than just using something like Zoom, or I don't even know if we had Zoom at the time, or YouTube or something that wasn't really made to live stream back and forth communication. So I tried office hours one semester for I think 2 of my 5 required office hours, and the feedback was good. The thing that I really liked was the population of students that used online office hours were different than the people that came in person. And so I still had people coming in person, but you could tell that there was a decent group of people that just never would have come in person because it was intimidating or they lived too far away or something. And at my university, we probably have more commuter students and working students than maybe most universities. So yeah, that's how I got started.
And then you transitioned to full online classes when the pandemic hit.
Yeah, and then I transitioned to full online classes, is right. And that was, I guess I was more ready for it than perhaps a lot of people were, because I had been doing all the Twitch stuff for so long. But yeah, that was, I guess
seamless
isn't the right word, but it was a lot easier for me than I think other people, to be sure.
Less bumpy. We'll call it that.
Yeah, exactly.
How did your...
I mean, it still was different because the students were, not used to it necessarily. So that they were still an adjustment for sure.
How were your evals at the end of the semester?
So I think they were the worst ever. In terms
okay, so
of
the standard held true.
Yeah, yes, exactly. Yeah, there was exactly. There was no real difference there. The students, I think we were all in, or many of the students in sort of the this is the first time I've done something like this mode, and yeah, it just wasn't great. Wasn't great, Bob.
So it goes. Our university basically just said none of these evals count over these 3 semesters. So for tenure or for
I think you
awards,
right, you could choose to include them or not, and they were still fine. It wasn't like it totally bombed, but I still included them, but they were definitely my worst ever because there's some students that don't like the online environment at all, no matter what you do. So it didn't really matter.
Yeah, makes sense.
Maybe I should explain the game.
Yeah, maybe a little bit.
If people aren't familiar with Kirby's Avalanche.
This is not a classic Kirby game.
Right. It's kind of like Dr. Mario. I think you have to get 4 in a row in Dr. Mario. Anyways, it's you're trying to basically
non-dairy neuter. Thank you for the follow. They came here for the explanation.
Non-dairy neutrino.
Neutrino.
I think so.
Apologize. All right, go ahead. How does this game work?
I recognize that. Right, so you have to get 4 colors in a row, and if you can create an avalanche, which is 4 colors that then trigger 4 other colors coalescing together, then you drop a bunch of, you take you drop a bunch of these clouds, I guess, on the other side, which get in the way of their progress, and so you're trying to get the other person to fill up their screen first, and they lose, kind of thing. So if I were good, which I used to be very good at this game, then I could show you one on cue, but that might take a little bit.
No worries. Mediocre gameplay, it's in the title. You don't have to lose sleep over that.
Right. Okay, good. So here's one. So the fact that the purple will get 4 together and then cause the green to have 4 together means I'm going to put a bunch of clear things on his side and hopefully mess him up, get in the way, kind of thing.
So I have a follow-up question about this game. What does this have to do with Kirby?
Yeah. Oh, absolutely nothing. I'm pretty sure they just piggybacked on his popularity at the time.
Yeah, I was going to say, this looks like a game somebody made,
it has anything.
And then they reskinned with Kirby in it.
Exactly. Yes, Open said exactly. It was all a not so subtle ploy.
I like it. Ninja Physics, thank you for the sub. 4 months. Did
anybody remember this game? Did anybody actually play this?
I did not. I played a lot of Dr. Mario, but not this.
I don't know what it was about this game. I remember Dr. Mario, but I didn't play it very much. So I'm not... It must have been just the timing of whenever this came out or it was available. Probably what it was is I played it at this summer camp I worked at, and they obviously only had the hand-me-down games and never got the good new games. So we probably got this game, and I was forced to play it.
Yeah. No, it's a love by necessity, right? It's available and you're going to play
yes.
it. Triboluminescent wants to know, who's Kirby? Did you play the other Kirby games?
Maybe twice. So not a bunch, no. So his power was sucking in everybody and spitting them out or something?
Yeah, so he'd suck them in.
I don't remember how that worked.
He could get various different powers if he had them in his mouth, and then he could spit them out as weapons. So
gotcha.
Yeah. Again, nothing to do with this game, but also this is getting stressful. Nice.
Yeah, it's I might be in trouble this game. We'll see.
Well, that's a perfect time.
One time I could definitely beat this.
It's a perfect time to open questions. Anyone in chat, do you have questions for Josh Melko? He's here to talk about atmospheric chemistry or science policy outreach, advising congressional people. Yeah, if you want to talk about that, beyond research, science advising and how you got into that one.
Me?
Yep.
You mean the science policy stuff?
Yep.
Yeah, I guess it was just something I'd been thinking about getting into. I felt compelled to do something that felt more applicable. I guess a lot of times shoot. Dang it. I feel like a lot of times I do very fundamental research, and so that's not always the most satisfying when it doesn't get used or doesn't find direct application in the world. And so I felt like science policy might be somewhere where I could have a really direct impact in the world. And I've been thinking years, but really only just recently found this program to, we're in trouble now, to give me a chance to do some science policy advising. No! So yeah, it was just, it's an opportunity through the AAAS, which is basically a huge scientific society that puts out the journal Science. And every scientific society, ACS, American Chemical Society, or Physics Society, or whatever scientific society you're a part of, selects a couple people for fellowships every year, sends them to Washington, D.C., and you get staffed in a office of a representative or a senator, and you kind of get some say where you want to work. And so in August, I'll be going to D.C. and be the science advisor for some senator. And it just seemed like I just got tenure, so it was the right time to apply for this thing and take a year sabbatical and go and do it and see if I could, change the world and give science a voice in D.C. And maybe it'll be miserable and I'll get all jaded, but it's worth a try.
Don't worry, we'll have Josh back on in a year, and we're going to see what happens. He'll want to play Excel or something.
Precisely.
It's just going to damage him entirely. All right. Spider Yen opens up with a very important question. What do atmospheric chemists work on?
That is a very important question. So it depends, which is a very satisfying answer, I'm sure. My section of atmospheric chemistry is the role of charged particles in the atmosphere. So you think about our atmosphere and it's mostly neutrals, and you think about nitrogen and oxygen, but the gases in our atmosphere are very different as you go up through the atmosphere. And you get a lot of charged particles the higher up you go, where they're interacting with sunlight when they're ionized. So my specific area of research is to look at how these charged particles interact with other neutral gases, because it turns out when something is charged, it can be sort of attracted to a neutral molecule more strongly than just two neutrals, right? So this permanent charge can be attracted, if it's positive, to a negatively polarized or a dipole of a neutral molecule, and that attraction sort of pulls them closer together. Whereas neutrals, you just sort of have to rely on them randomly finding each other in the atmosphere. So these ions reacting with molecules is actually a pretty large trigger on climate, day-to-day weather, these things. So that's certainly my interest is thinking about how these charged species affect things like the ozone layer long term. But other people study aerosols, which are kind of a huge thing. How salt from the ocean gets up into the atmosphere. There's all sorts. When meteors come in, one thing I studied for a little bit was when meteors come in and deposit a bunch of metals into the atmosphere, that can mess with radio communication and have all sorts of negative impacts. So yeah, depends.
Makes sense. TTU Geography, thank you for the raid. Hope your stream went well. Welcome to Ask a Scientist Gaming. If you have questions for Josh Melko, atmospheric chemist, science policy advisor, and Kirbys Avalanche player, feel free to throw them in chat.
Loser right now. Kirbys Avalanche loser as it is.
No worries. Tribal luminescence. A related question to charged particles. Where does lightning come from?
Where does lightning? So any discharge, right, is a difference in potential, where in lightning's case the air is conducting this discharge of electricity. So in much the same way you can, one example I always like to give or think about is when you smell burning electronics, you're actually smelling ozone, and it's an electrical discharge in the electronics that fractures the oxygen molecule, which then meets up with another oxygen and makes O3 ozone. So in much the same way, the smell of lightning is this electrical discharge due to a potential difference in the atmosphere and the ground. that fractures apart oxygen, which then combines with other oxygen to make ozone. And so that definitive burnt electronic smell or lightning smell is actually the molecule ozone you're smelling.
Very fun. And Scuzzbot has redeemed Take a Drink. So, Josh, you can't really pause during game, can you?
No.
Cheers. Thank you for stopping by. We're happy to have you on Ask a Scientist Gaming. Yeah, it's going to be an awesome night. And so, cheers to everyone. Thanks for joining us on a Wednesday night. Hopefully you're drinking with us.
Yeah, man, I'm thrilled to be here. This is such a cool concept. I mean, I don't know of anybody else doing this. People do interviews, but I'm not sure they play games while they're interviewing, and I've never seen it especially done in oh man, I'm gonna lose again here, aren't I? In a science context.
Yeah, there's something to be said about the humanizing nature of sucking at video games. Like, it definitely knocks us off our ivory tower while we talk pseudo-intellectual. So,
Exhibit A. I can't even get past stage 3.
All right, we'll start. We'll keep going with an easy question. What's your favorite gas?
Wow, that's supposed to be easy? I mean, they're all my children. They're all my children. How do I pick?
It's nitrous oxide.
No,
that was
nitric oxide.
Nitric oxide, sorry.
No. That was a joke. No, nitric oxide. Okay, anyways, probably ozone, actually, which I know I already mentioned, but I've studied it a lot. Really strong oxidizer. I think the Montreal Protocol and, you know, the destruction of the ozone layer was something that had such a, you know, crossed over to the everyday person. You know, everybody's heard of, you know, the ozone layer and the destruction of the ozone layer. And the fact that we identified as a world a problem and instituted the Montreal Protocol to try to repair this problem, where the problem was these chemicals that man made was basically eating away at the atmosphere. So we banned the chemicals and the ozone layer started to be restored. I think that's just so cool and a real achievement. Probably the greatest achievement before COVID in terms of like a international worldwide collaboration to do something positive for humanity. Yeah, so I guess ozone.
So you're saying free market capitalism did not solve that problem?
Turns out no. No, it
Who
did
knew?
not. Marx was right.
Follow-up question on that. I will get back to Ninja Physics and Spider Yen. Calm Down Bronco wants to know, how is ozone restored in the atmosphere?
Yeah, so it's actually a pretty natural process. So, you know, all these things are sort of balances, right? Like something generates it and something takes it away. You know, energy in, energy out gives us the average temperature of the Earth. But if we prevent energy out, then the global temperature rises, and that's what greenhouse gases are doing, right? So ozone is both produced and destroyed quite naturally in the atmosphere. It is made because oxygen, which has a double bond high up in the atmosphere, there's sunlight. Well, there's sunlight lower in the atmosphere too, but there's more dangerous, right, lower wavelength sunlight further up in the atmosphere. And so that sunlight is capable of breaking that double bond in oxygen. And when it does, you then liberate these two oxygen atoms. And so those two oxygen atoms that are now free, one of the oxygen atoms will go and find an oxygen molecule. So it's O plus O2, and that will make ozone O3. So it's generated from sunlight ripping apart oxygen and combining with other oxygen. It is killed by basically anything ozone bumps into, it's going to react with, so it's such a strong oxidizer. Ah, shoot. Man, this is terrible. So it's a very strong oxidizer, and it basically will give away its oxygen to almost anything. So there's this constant balance, and that's part of what I study is the kinetics of how fast those things happen. And so it's always being made. What we did with chlorofluorocarbons is basically increase the rate at which it reacted away. It's still being made all the time, but if we increase the rate at which it's etched away more and more, you know, then the scales tip to the other direction and we have a net loss of ozone. So just by like removing those dangerous chemicals, eventually the Earth will sort of heal itself.
All right, Texas Space Agency says hello. Also says endless love for y'all. We appreciate it. We love that people want to join us for science, drinking, and video games. But their question is, ozone up there good, ozone down here bad? Question.
Right. Yes, pretty much, because ozone up there is one of the great things about ozone is it's a absorber. It's a broad absorber of sunlight, and so many of the dangerous UV energies that would fry us. If we didn't have ozone, basically, we couldn't walk outside for very long before we were sunburned. Like, we're talking seconds to minutes. But ozone up in the atmosphere is able to absorb broadly a bunch of different radiation. So you have ozone absorbing, 240 nanometer light, which is really dangerous, and a whole range of UV energies. So up there, it's good. Down here, it reacts with everything and eats away at us, at plastics. So down here on the surface of the Earth and the troposphere, the layer of the Earth we're in, and the layer of the Earth, all of you will only ever spend your life in. Only the troposphere. Even if you fly in planes, only the troposphere. Now, maybe you take a ride one day with Elon, then okay, you'll leave the troposphere. But other than that, you're always going to spend your life in the troposphere. You won't even get to the stratosphere, which is the next layer where all the ozone is.
Feel sad. Spider Yen wants to know about the ions. Do they form some kind of plasma?
Do they form a plasma? No. So the densities, the higher up you go in the atmosphere, the thinner the air is. And, plasmas usually are pretty dense mixture of differently charged particles. So they're not forming a plasma. They don't form from a plasma, but the charged particles mainly, well, I should take that back a little bit. The charged particles mainly form from sunlight ionizing molecules in the atmosphere, and then these charged particles go and react with other neutrals. You can have plasmas, which are sort of localized areas of charged particles that do really get in the way of radio communications. And one really cool thing that we don't think too much about, especially not these days, is that the whole way we could communicate over the horizon, like the whole way the United States could communicate with Europe back in the olden days, right? When, some of you in the chat, I'm old, so back in the olden days when I was born, you didn't have, all these satellites that could relay messages, and the only way you could really get a message over to the other side of the world was bouncing it off the atmosphere. And what you're really doing was bouncing it off these charged particles in the atmosphere. And sometimes those are called plasma layers. Although they're not really how you typically think of plasmas.
So correct me if I'm wrong, but Aurora Borealis, isn't that a plasma? Isn't that an ionizing gas?
So Aurora Borealis is nitrogen. Basically, the triple bond of nitrogen is very stable, but high up in the atmosphere, there's strong enough light to fracture that. And then these nitrogen atoms way up in the atmosphere and oxygen atoms way up in the atmosphere get excited. Some of them are charged species sometimes and congregate around the poles, but really what it is it's sunlight exciting these nitrogen atoms and oxygen atoms that then relax back down and give off this green light. So I don't consider it a plasma, but it probably depends on who you talk to. How are you going to define plasma? I usually think about it as more dense.
Yeah, it's just normal excitation emission process with a really exotic set of molecules. That makes sense. All right. Bronco, thank you for 4 months. It's always a pleasure to have you here. Feel free to throw your questions in chat. We are slowly catching up to them. A lot of good questions that we're going after. All right, Ninja Physics wants to know, what do you think the ramifications of greenhouse gases shrinking the stratosphere and mesosphere?
Greenhouse gases shrinking the stratosphere and mesosphere.
So Ninja Physics, wasn't that a paper like this week? It was some brand new study that said, like, the stratosphere and mesosphere were dropping because of that. I don't remember the details. I didn't read that full paper.
Yeah, I guess I'd have to read because, the atmosphere layers are really differentiated based on what temperature is doing in those layers. So, in the troposphere, the higher you go, the colder it is, right? You climb Mount Everest, you get colder. But in the stratosphere, where you have all this ozone that's absorbing a bunch of sunlight, the temperature inverts. So as you climb in the stratosphere, it gets warmer, which is a little counterintuitive to what we experience here in the troposphere. And then in the mesosphere, the temperature goes back down. So the different layers are really differentiated based on what the temperature is doing. So if they were changing where the layers were, then that's because where the temperature is changing is moving in altitude. And that could be a result of where ozone is settling out, for example, and where it's congregating. So, there are these really cool maps. Maybe somebody, if there's one of my viewers around, they know this. I think it's Earth Null or something like that, Null. Anyways, it's a really great visualization of the atmosphere, and you can see all these different layers and what the layers are doing. But the chemistry and the wind currents and all this at different layers is due to different densities of certain molecules. So if that's changing, then it undoubtedly would affect our climate. I just don't know offhand exactly how. But yeah, that's scary. If you do have an article, or you can paste a link in the chat, I'd love to read about it.
Earth.nullschool. Sorry, I'm looking it up. They have it in chat. Earth.nullschool.net.
And you can filter based on like ocean currents. You can look at how much carbon dioxide is in a certain, and it's worldwide. You just spin the globe and it'll show you like what's doing what where. It's really cool. You can look at how much China is polluting the atmosphere.
That is beautiful. All right, I'm gonna hijack
it's
your
really
background
great
for a second.
And it's all live. It's like, it might not be live, but it's maybe a day old or something like that. So it pulls from NOAA and NSF and all that. Hey, Pliers, thank you.
That is beautiful.
It's really, really cool. So there's a little menu in the bottom left where you can look at CO2 or wind currents. And so one of the ones I love to look at is wind currents as a function of atmosphere. And you can see just how chaotic it gets. The winds are moving one direction down here in the troposphere, and then all of a sudden, a little further up, they're going like chaotically a different direction, or all these like little eddy-looking things, which is really cool.
That is a really nice interface.
Yeah, so it's great.
Who produces this?
I forget. You'd have to go to the
I'll take a look.
Section, but it's pretty neat. All right, I gotta beat this guy. This is enough of this, okay?
It's time to focus.
Let me get through this.
You want me to hold off on questions?
Yeah, give me. This guy's dead. All right, here we go.
Now it's personal.
Yeah, this is. Oh, I really screwed that up. All right, now I need a blue and then a green. Oh, so help me God. Any blue.
Yeah, Ninja Physics. Scuzzbot just shared the link in chat of the mesosphere shrinking. So I'll share that with you after the stream. But yeah, that was this week. It came out. I'm assuming it's one of the Journal of Atmosphere and Solar Terrestrial Physics.
Yeah, I'll definitely have to check that out. My guess is it's something about the temperature gradients are changed based on where different gases are settling out. So, I mean, gravity is constantly pulling. Yes.
Call it a victory.
Yeah. Gravity is constantly pulling stuff in, whether it's dust from sort of outer space or heavier gases settling back down in our atmosphere. So, if these heavy things are absorbing energetic light, then that heats that portion of the atmosphere. Or if it's something like ozone that really absorbs broadband UV light, it can warm the atmosphere. So yeah, it's a pretty complex chemical soup, which is why I love it.
That's fun. All right, so we have Triboluminescence wants, yeah, trying to distract you. Is physical chemistry fun? Interesting? Yes.
Yeah,
All science is interesting here.
That's my mod. Don't pay any attention. In fact, I would love if you banned him permanently from the channel. No.
Thanks for stopping by, Tyrion. We appreciate it. All right, Triboluminescence wants to know, how do you figure out reaction kinetics when you're doing your experiments, we'll say? We'll narrow it down to that.
Right. There are certainly different ways. I guess how do I probably want to keep this at the surface level. So basically, you have a certain amount of A plus B, if that's the reaction. You have a certain amount of A, and you can just flood the chamber with B, and you're looking for a certain product C, right? So, jeez, this game.
He blocked that. That was ruthless.
I know.
No, you're right. That merits a rage. We have
Thank you.
That's Aaron Vanucci rage
emote.
emote. He is our first rage quit on Ask a Scientist Gaming. It was during Madden 2007.
That's awesome. That's a terrific emote. So basically, we measure the appearance of some product ion. So this is all done in a mass spectrometer, which is under vacuum. So basically, in the gas phase, you have to get all the other gases away, and then you introduce the gas you want to study, gas A, and then you slowly feed in through this device that measures the flow, so you know how many molecules are going in. You exactly sort of let in a certain number of molecules of B, and then you measure how much of molecule C you're generating. And this is pretty straightforward differential equations to figure out, as a function of how much B I'm adding, how much C shows up. Is that a squared relationship, which we would call second order kinetics, or is it a linear relationship, which we call first order kinetics? And based on the different kinetics, first order, second order, you can figure out basically how fast things are reacting and the dependence on concentration. I love this guy.
These are who you're fighting?
How fast how fast things are reacting based on something called the rate constant and the concentrations. So, that's a long-winded answer of saying you get everything out of the instrument, you slowly introduce the two things you want to react, and then use a mass spectrometer, which is a weighing device, to discover this third molecule. And it's appearance of this third molecule and the depletion of the other two molecules.
All right.
That
Pause.
Will either be linear or logarithmic or something like that.
Pause. Do you want to put a prediction on this game? Will you win this round?
Oh yes,
All right.
I would love to put a prediction on that.
Time to spend some imaginary internet points here. Will Josh win this game? Just this round, yes or no? We're going to give people 2 minutes so you can chill out and explain things as thoroughly as you want, because you don't have to play while the prediction's going. All right, spend your imaginary internet points. Our standard internet units, for those of you just joining, check the bottom left corner. Click on it, spend those points. Bet on whether you think Josh will take the win here or not. So it gets harder as you progress through the game, presumably, right?
Yeah, and I think, I guess I won't give away any information, but I've been losing a lot, so it's not it's not a good sign.
Oh no, we have believers. No, under pressure, you're gonna come through on this one. I like it.
Under pressure, I'm gonna take my earbuds out and close the chat window and just focus.
I like it.
Focus.
All right, Penguin Sox wants to know, what do you think about weather modification like cloud seeding?
I am for it, especially on other planets like Mars, to try to make its atmosphere a little bit more hospitable. So part of the problem is, like any new technology, it can be used for good or evil, and generally people are scared of the evil things. But without going too much into it, like there are definitely experiments that have been done into modifying the atmosphere for what I would consider nefarious reasons, in terms of like wartime things, and then also really good reasons for restoring the ozone layer or something. So I think, especially in terms of climate change and the accelerating pace of our temperature on this planet, we're kind of out of completely safe, non-controversial things to do. And even the things that seem reasonable won't get like through the U.S. Congress anyway. So that's why I'm for what you might consider more aggressive weather modification, because honestly, we've sat on our hands for far too long.
All right, so the prediction window is closed. Josh, do you want to know the betting ratio, or you just want to play?
I want to know. If these people have my back or not.
We have 7 yeses and 5 nos. But the yeses only bet 640 and the nos bet 1,000. So the nos are fewer but more confident.
All right, here we go. Let's do this.
And Tyrion's prediction is not based on ability but on personal desire.
Okay.
All right. Weather modification. All right, going forward. Oh, these 2 questions are related. So Tribal Luminescence wants to know, are there atmospheric catalysts? But Bronco asked a question earlier, how do the aerosols and man-made chemicals destroy the ozone in the atmosphere? How specifically do they react? So very specific example of catalysis in the atmosphere.
Right. Can you repeat that? I was really concentrating hard.
We put too much pressure on you. All right. We'll start with this one. How do the aerosols and man-made chemicals destroy ozone in the atmosphere? Like, how do they actually react?
Oh, sure. So, the chlorofluorocarbons are really, really stable down here on the surface of Earth. So we've used them in refrigerants. Part of the reason is because they have great Joule-Thomson coefficients, which basically just means as a gas expands, it cools. And so if you expand this gas near food, it will cool down your food. So we use them as refrigerants, which is great. And what was really cool is that they seem to be stable and don't react with a lot of things. But when you get them up in the atmosphere, there's, remember, this really dangerous sunlight that's high energy. And that high energy sunlight is able to fracture the molecule apart. So a chlorofluorocarbon is basically a carbon with a chlorine and a fluorine. But when it gets way up in the atmosphere, that can be fractured apart and make just a chlorine atom. And this chlorine atom is incredibly reactive. So what ends up happening is this chlorine reacts with an ozone and turns the ozone into oxygen O2. So a single chlorine molecule will destroy a single ozone molecule. But the product of that reaction is ClO. And this ClO also reacts with ozone to destroy ozone, to make oxygen. So basically you have this repeating, never-ending cycle from a single chlorine atom that ends up destroying a whole bunch of ozone. And it's, photochemistry, because a photon, sunlight, initiates this process. This is not looking good for me. Can he come back?
I'm going to give you a little bit of time.
The 8-ball says no.
Believers have faith. It's very stressful, the random drops of the black ones or the clear ones.
Yeah, I concur.
Focus. It's stressful. I'm investing.
All right, here we go.
I can't even make predictions.
This is where it changes.
Tides are shifting.
Coming back.
All right. That's just, should I feed you a question and then ruin that?
Yeah, it's fine. 'Cause I got this. He's about to get.
Penguin Sox wants to know, Ken and Josh, how do you play, read, and talk at the same time? Well, the thing is, I don't play at all. That is not me playing in the game. Oh, that was so close.
I think teaching. Oh no! Oh god. Okay, it's close again. I think teaching on Twitch has helped because I am trying to like keep up with a bunch of chat. Oh god. But I mean, it's not easy, but you get used to it.
Staying alive.
Oh no! That's it. That's it. This is how it ends.
Not like this.
Oh crap!
Oh, it was a valiant effort. You fought back several times. All right. Choose an outcome. Will Josh win this game? No, but it was a good fight. So congratulations on those of you that didn't believe in Josh at all. I hope you feel good about yourselves. Standard internet
little
units
do you
to the
know,
skeptics.
I actually bet all my points on no, and I threw that game.
Oh man, we got some insider betting here. Scuzzbot redeemed. Take a drink. Cheers, Josh. That was a valiant effort. Well done. Yeah, we'll keep hammering away at questions with less pressure this time. So do you get to indefinitely keep playing the same person? Or is there like lives in this?
I think. I don't know. There's no cheat codes on or anything, but I think you can just keep continuing forever. Yeah. At least that's the sense I get.
Triboluminescence wants to know, are there atmospheric catalysts? You talk about chlorofluorocarbons already. Are there other examples of atmospheric catalysts?
Sure. So I think I might have mentioned this earlier, but or no, I guess I didn't. I've studied a lot of metals and how they react in the atmosphere. And you don't typically think of metals in the atmosphere, right? But when meteors, come into Earth, they deposit and they burn up, right? And they deposit metals. So, man, this guy, Squishy. These metals that they
Your arch nemesis.
these metals that they deposit are really, really reactive. And a lot of what meteors are made of are things like nickel and iron, these transition metals, which are in the center of the periodic table, and they have a lot more electrons with which to like bond things and carry out chemistry. So when metals like that are introduced in the upper atmosphere, they tend to be able to react with a lot of things. And so when a meteor comes in to the atmosphere and deposits a bunch of iron, that iron, actually we've shown in one of our papers, catalytically gets oxidized by ozone. And similar to the chlorofluorocarbon chemistry I mentioned earlier, it destroys a bunch of ozone. And before that study, I don't think a lot of people were, I don't think a lot of people were thinking about ozone destruction from metals. And so we, I think, changed that to some degree and found the same thing with nickel. Basically, when a meteor comes in and burns up, it puts a bunch of metal in the atmosphere. Those metal atoms can catalyze a lot of different reactions, most notably as we studied with ozone. You also have different like nucleation that happens, especially lower in the atmosphere, where things like salts and aerosol particles can be the growth mechanisms for whether it's cloud nucleation or other growth processes. On other planets that have different chemistries, you can get things like, methane and methanol cloud formation from seeded aggregation and growth processes.
I just want to take a moment to celebrate Josh's victory there. He completely glossed over that because he was talking science, but that was a quick win.
Yeah, I mean, it's funny. Like, I think the randomness really plays a huge role, right? Into where, like, the thing gets dropped and totally messing somebody up or not.
Suppose, luck of the positioning. All right, Calm Down Bronco wants to know, what is Mars' atmosphere like and how does it compare to Earth? And Shmonite, add to the Calm Down Bronco's question, can there be lightning on Mars? Fun questions.
Ooh, that's a great question. I don't think there can be lightning on Mars, although I'm not totally sure about that. Lightning depends on the like how dense the atmosphere is, and Mars is about 1% of Earth's atmosphere. So on the surface of the Earth, it's 1 atmosphere or 760 torr. Torr is a unit I use a lot in my laboratory. On Mars, it's about 1 torr, so maybe a few torr. So it's like 1% of Earth's atmosphere. So it's much, much thinner. And
so compositionally, how different is that 1%?
Yeah, so it's almost entirely carbon dioxide down at the surface on Mars. So yeah, I mean, we can't breathe it. A lot of people think the entire atmosphere of Mars is carbon dioxide, and it's not at all. As you go up in the Martian atmosphere, sunlight initiates a lot of photochemistry, and there's actually more oxygen atoms in O2 than there is CO2, or I should say oxygen atoms and carbon monoxide than there is CO2. So it kind of depends where in the atmosphere you're talking about. Almost everybody usually is just talking about the surface, because us humans, only think about ourselves walking across the surface, and so we say, oh, it's all carbon dioxide, and it is at the surface. But the further up you go, the more complicated it gets in the Martian atmosphere. And there's been some wonderful data from NASA's MAVEN mission, which is flying around. It's a satellite that flies around the Martian atmosphere and takes these dives and samples with a mass spectrometer what is happening in the Martian atmosphere. So we know now a lot better than we used to that the Martian atmosphere is quite complex, and more complex than we thought with all this other stuff. But it is mostly carbon dioxide. This is not good.
No worries. Once Cuzbot just put a link in chat about why Mars lightning is weak and rare. So it's probably exactly what you said.
Yeah, so it's very much thinner, so it needs, the arc has to arc through something or discharge through something. And there's this thing called the Paschen curve, Paschen, which basically plots out as a function of pressure what is the chance for a discharge event. And it's not like linear, right? It's like a Nike swoosh or something kind of curve. And, the likelihood of a electrical discharge is actually lowest around 1 torr, which happens to be what it is on Mars. So it's not impossible, but it's basically the kind of conditions you would expect to not get a discharge. And this is why in certain instrumentation, vacuum instrumentation in the laboratory, a lot of times you're worried about arcing at, moderate pressures, right? Different pressure ranges, but there's certain pressure ranges where you don't expect it to happen at all.
All right, Hamsterlicious wants to know, what role does quantum theory play in physical chemistry? I remember walking in on a PChem class and being surprised to see wave function integrals, which we typically use in physics to talk about probability distribution of electron locations.
Yeah, I mean, I would say the whole point of physical chemistry is to do the physics in chemistry that the rest of chemistry is scared of, right? So it is quantum mechanics and thermodynamics, but I think what really separates physical chemistry from the other chemistries is the involvement of quantum mechanics. Not to say it's not present, but at least when we're teaching it, physical chemistry is more rigorously mathematic than the others chemistries. Oh, are you kidding me? That's the one place I could not afford for it to go. So yeah, when I teach quantum mechanics, when I teach physical chemistry, I should say, one semester is thermodynamics, the other semester is quantum mechanics. And we don't go quite as technical with a physics course on quantum mechanics, but because we want to see, how the wave function describes chemical bonding and how it plays with spectroscopy, and so we don't spend nearly as much time. We do like particle in a box and particle in a ring, but we sort of stop there. So yeah, I mean, physical chemistry is really about merging chemistry and physics. It's that interdisciplinary field. So we definitely cover Schrodinger's equation and particle in a box and go from there.
Uncle Bill Drone, thank you for the follow. And the question for you is, why would we ask Florida Man anything?
Me?
You're correct.
Or are you talking about the other Florida man here?
That's true. We're both Florida Man, so I wasn't born
chemist,
in Florida,
thank you.
So I don't know if I count.
That's true. You're fake Florida man.
Exactly.
Chemist, thank you, man.
I'm a tourist. Little Chemist, thank you for stopping by. Throw your questions in the chat if you have them. All right, Ninja Physics, related to science policy and atmospheric chemistry. There's been some concerns using sprayed polyurethane foam insulation because the blowing agents are potential greenhouse gases. How do you think this will harm the effort to insulate homes in preparation for renewable energy transition?
That depends on who at the federal level, probably rather than states, is advocating it for its use, and who is responsible for writing legislation to control that with regulations. So I mean, the short answer is, if what you're saying is true, and I have no reason to believe it's not, that's going to be a matter of how is it regulated by the EPA or some other federal program. But yeah, that's potentially pretty terrible. There is a lot of different insulation technology out there, though, right? Didn't NASA, I forget exactly what it is, but NASA has, like, whether it's aerogels or these other things that's supposed to be like the latest, greatest thing to insulate your homes, although it seems like it's been that way for years and never quite come to fruition.
I mean, that's one of the most tragic stories in science, is when somebody tries to come up with something to make it better and ends up making the world worse. So I mean, go ahead.
That's basically what has happened with HFCs. So, I spoke about the Montreal Protocol earlier, where we, this great achievement, and it truly is, banning chlorofluorocarbons, which ate through our ozone layer. But what did the man do? And really by man, I mean chemists. What chemists did was you banned chlorofluorocarbons? Well, what if we replace one of the chlorines with a hydrogen? It's not technically the same thing. Yeah. So we have HFCs, right? And HFCs are basically, they're not quite as bad, but they're still really terrible in the atmosphere. And so yes, we fixed one problem, but we sort of created another. Although I will say it's a cynical view, I think, to assume that that's not worth it, because everything you learn about with this, legislating the policy and then putting it into practice and making your observation, none of that is wasted, because as soon as you realize then HFCs are a problem because people are studying it, then you're very quick to ban and make regulations and, attach regulations on top of the existing protocol. So, some people have argued that, it wasn't a success because, the chemists are just going to make something that's a one-off and just as bad, if not worse. But the whole thing shortens the time to implementation in a way that I think makes it all still worthwhile, if not ideal. Hopefully that made sense.
Yeah, that made sense. So is it the same guy that came up with CFCs also came up with the leaded gasoline, right? The tetramethyl lead to prevent knocking.
I did not know that, but It does not surprise me at all.
No, I mean, I by the end of his life, he had to have known all this was going terrible, but he thought he was doing genuinely good stuff. Right. That's super tragic, unlucky discovery path. All right, we're going to lighten up the mood. We're going to throw another prediction up in chat. So I ask all my guests to come up with predictions before they come on, and Josh came up with some of the most out there predictions I've seen. So the question is, which can hold its breath longer, dolphins or sloths? You spend your imaginary internet points right now. Which one can hold their breath longer, dolphins or sloths? You guys have 2 minutes to throw your votes in there. Did you look this one up somewhere, or was this one in the back of your head?
I looked it up.
That's fair.
But I was trying to find things that were kind of close.
I mean, that's an interesting comparison, and I look forward to hearing. Do you have an explanation as to why the sloth needs to hold its breath? But we'll wait until the predictions are done.
Right.
All right, Triboluminescence wants to know, what kind of physics theory can be used to explain kinetics?
Many, but what is physics really but just like the language of math explaining the world around us? So all of kinetics is basically differential equations, and the change of concentration of one atom or molecule and how that affects the subsequent chemistry. So it's basically all differential equations. On top of that, I would say when molecules are near each other in the gas phase, oh boy, that was a lot. There are Coulombic attractions that govern how they find each other. So, you typically just think about, and it's taught at the elementary level in chemistry, that kinetic gas theory, these things are just like rambling around in a room and bouncing off like billiard balls on a table. But, what's really happening is that some of these molecules pull in other molecules based on ion dipole forces and Coulombic attractions. And so I think it's really cool to run these things called trajectory calculations. Oh my God. Which tell you, he just destroyed me, which tell you the role of things like angular momentum in affecting reactions. So, if you have these two things in the gas phase that are sort of careening near each other, well, they're also tumbling through space, right? And they also sort of attract to each other based on, through the long range forces, charges, like charges repelling and opposite charges attracting. And so, I mean, in terms of another area of physics, the angular momentum and spinning of one molecule actually can affect what it collides with and the orientation of the molecule necessary to promote some sort of chemistry.
All right. RKOD, thank you for the follow. Anyone just joining us, this is Ask a Scientist Gaming. Our guest today is Professor Josh Melko, expert in atmospheric chemistry, also getting to be an expert in science policy advising, and playing Kirbys Avalanche, winning some games, fighting the good fight against, I don't know who you're against right now. Whatever that purple thing is. Bugsy, there we go. All right, Scuzzbot has a really broad question. Can you talk about the makeup of Jupiter? Some fun gas phase chemistry.
No, I know very little about Jupiter. I'm just gonna be
That's the gas giant. What are you doing with your life?
I don't exceed the rocky planets, so I stop at Mars. All right, Mercury, Venus, Earth, and Mars. I do know that there's obviously a ton of hydrogen and helium and several light gases, but I do know it's so massive that the pressure on the inside of Jupiter, it is theorized that the pressures are such that hydrogen can be not fused like it can in the sun, but exist under these crazy chaotic pressure environments that make hydrogen behave very differently and almost like a metal. So you get these insane pressures on the inside of Jupiter that give you some really, really weird chemistry. And yeah, I don't know offhand the makeup of Jupiter, unfortunately.
No worries.
Although I was born in a city called Jupiter, so I should really know much more about it.
You truly are the Florida man. Jupiter, Florida.
Yeah, exactly.
That's awesome.
Yeah, this is, I really thought I would be better at this game.
I mean, is it...
Oh, are you kidding me?
Is it you're not good or you're playing while talking science?
Yeah, let's go with that one.
No, it's no joke. It is so non-trivial. Like, I speedrun the shit out of Mario, but having to do it on camera while playing games, not a trivial task.
We definitely are at like the stages now where it gets very fast and hard to do anything productive with.
Yeah.
Oh. Okay.
No
There's
worries.
hope yet. There's hope yet. Here we go. Here we go.
Wow.
Yes! I'm back, baby! Take that! He's done. He's done.
Oh, the come from behind victory. Well done, sir.
Okay, I need a refresher here.
All right, cheers on the victory.
Exactly right, hamster.
To a first-ish order approximation, Jupiter is just
It's a
ball of
spherical
ideal
cow
gas.
in a vacuum range.
The spherical cow of PV equals nRT. It's mostly hydrogen and helium. I mean, that makes sense compositionally.
Yeah, that's kind of what I figured.
At least that's what Uncle Bill says. If we are to believe Uncle Bill.
Uncle Bill's never led me astray, so he is one of the founders of the Knowledge Fellowship, which is a group of educational streamers I'm a part of here on Twitch, and I think you're in that Discord too, Ken.
Yep.
But yeah, there's a whole bunch of people that do educational content on Twitch. Mostly people think it's gaming or these days like hot tub streams or something weird, but there's actually a good group of educational people that I absolutely love on this platform. And yeah, Bill was one of the first people to kind of take a look around and start to congregate educational people together.
I mean, that's an obvious follow-up, though. What about an educational hot tub stream? Have you tried that yet?
No, I think I have A, some level of self-respect, and B, I don't want to subject viewers to that. Like, that's nobody, come on. I am so, look, maybe I was tan once as a Florida man, but now my neck is like bright red and then it's just like pasty white. And you don't want to see that.
I like it. All right, so we're going to tap into some of my questions. One of my favorites, that I have watched a shitload of movies. What movie or TV show gets your discipline right and what gets it wrong?
What gets it right? The Martian. It's a lot of it right.
Good one.
Especially the book. Oh boy, I'm done. Yeah, especially the book. That guy really did a ton of research. And he's the same guy that wrote The Egg, which is a really, really great short story, if you've never read that. But yeah, the movie was also really, really good at making sure the science is right. So The Martian, 2 thumbs up. What gets it wrong? The one that always comes to mind is Armageddon, because like it's ridiculous. But like the fact that we wouldn't see that asteroid like way earlier, and then there's fires on the asteroid.
Good point.
In space, it's like fires in space, and then they like drill a couple hundred feet down to inject this bomb, and like that would be nothing but merely a flesh wound, really. Like that would do nothing. So yeah, that movie triggers me, and not just because of the stupid song by Aerosmith, I think it was.
Stupid song. You take that back,
you
sir.
can sing it.
I Don't Want to Miss a Thing by Aerosmith? No, I've never heard of it.
That's right.
That was like our senior year of high school.
Wow. Feels old.
Yeah. Oh, Scuzzbot critiquing the tipping over the launch vehicle with Mars wind. The Martian. Shouldn't have been Mars wind.
Fair.
All
I mean,
right.
Mars is pretty chaotic, and they have dust storms and things. But it is very thin.
Makes sense. Hamsterlicious recounting a story about one of his professors with a heavy accent. I spent the entire lecture thinking he was somehow trying to reference spherical cows as some sort of model for what we were discussing. That's fair. That's fair. All right. Lil Chemist wants to know, do you have a favorite planet aside from Earth or Mars?
Jeez, well, there's only, what, 6 others to choose from. You know, it used to be Venus, but then, like, all this crap about life on Venus, I'm totally off of Venus now, and that's, like, somebody else can have Venus. There's not life on... We should talk about that as well, but people might have heard of that. I guess Saturn, because, like, how cool is it? The rings you can see with a decent telescope. Like, yeah, Saturn. I would say is my favorite. After those two.
Triboluminescence follow-up, is there life on Venus?
You know, you never want to say never, but I would say it's extremely unlikely.
Ooh. I'll follow up.
You know,
Oh, go ahead. Explain why it's unlikely.
Well, I guess maybe unlikely is the wrong way to say it, but they came out, there was this very big press release and huge event about there being life possibly discovered, on Venus. And it's the signature of this molecule called phosphine. And, you know, phosphine isn't really anywhere on Earth except where life is. So the fact that they saw phosphine, they were thinking, you know, that might mean that there's life on that planet. And, you know, we've actually deduced that it's very likely phosphine and it's not some arbitrary signal. But then, like, I read the supplemental material of the paper, and their kinetic models include no sort of metals in the atmosphere, which catalyze a lot of things, especially phosphorus chemistry. So that was like a red flag to me. And since then, it's come out that their data was more noisy than they represented. And I don't think they had like evil intentions. There was some clap back from other experts that suggested looked at this data and analyzed it wrong, and then since then, the other telescope data also has looked incorrect. And so it just seems, you know, what is it? The simplest explanation is usually the correct one.
Occam's razor.
Occam's razor. Like, it's probably just chemistry we don't understand, or it's a bad signal. It's probably not life on Venus. Now, I could definitely be wrong, but like the burden on proof is like not on me. So you better have like a ton of evidence that there's life there, and they just really didn't. And I don't know, I think the whole thing was a bit of an embarrassment. Now, if it means that we get money to send some satellite to Venus to look for this thing, I'm all for it. That would be fantastic. But yeah, I didn't understand after reading the paper and the other papers how it escalated to the point where, like, this was national news. It was on Today's Show and everywhere that, you know, did we discover life on another planet? And no, I hope in my lifetime we do, but I don't think it's phosphine on Venus, but I could be wrong. I'm willing to risk that.
Yeah, so apparently Uncle Bill's been keeping up with it. It's still up in the air. Latest paper says it doesn't have enough silver to explain all the signal. So that's the metal catalyzed phosphine generation you were talking about.
No, I mean, I was thinking more of iron or nickel or something common in meteorites. It's just like completely missing from their kinetic models. And I think it's like there's several avenues in like the phosphorus community. Not necessarily like phosphorus in atmosphere, but in phosphorus community, iron is like well known to mediate a bunch of phosphorus chemistry, and like there's a bunch of iron in meteorites that are entering Venus every day. So
if
it's just, is it at levels necessary to explain their signature? Maybe.
So if you had to bet imaginary internet points on it, what planet or moon would you guess would be most likely to have life on it? And Scuzzbot particularly asked life on Europa.
Yeah, so Europa, Titan, and Enceladus, but probably Europa, right? Wait, shoot, I screwed that one up. Which is so? Is it, I'm trying to remember if it's Europa or Titan, but I'm pretty sure it's Europa. That there's this. We have really solid evidence actually for the fact of a liquid underneath the surface, and it's probably a salty liquid. Like that's where my money is. Now that's to say we could, like, I wouldn't say I'm hopeful, but maybe slightly optimistic that at some point we see some evidence of old life that's not alive but is now dead on Mars, right? Because there was clearly water there, so it's entirely possible that we find out there was at one point life on Mars, and that would be extremely cool. It might not be active life, but like, who cares? That's still really cool.
All right, Natty Science, welcome. Natty Science is from St. Cloud. So I'm originally from Minnesota. St. Cloud State University is where I went to undergrad. So crazy
nice.
Small world. Welcome. Glad you joined us from St. Cloud. We're talking atmospheric chemistry and science policy with Josh Melko, also playing some Kirbys Avalanche. You are 1 hour and 10 minutes in. Do you want to change games or you want to keep grinding? You going to go for the victory?
I'm going to grind a little bit long. Yeah, I want to beat Heavy Mole. Like, if you probably aren't paying attention, like to the subtleness. That is Kirby's Avalanche, but the background has been like slowly developing, and this stage of background is like the hardest set of people. So Heavy Mole, this guy is like the beginning of the hardest level of bosses. So I will feel good if I can beat him at least.
Dr. WD40 has the most important question of the night. Did Melko just sip a Bud Light? And the answer is kind of.
Yeah. So I found. I have a bunch of different. So we started with Land Shark with a lime. It's a lager. But this, I'm gonna get made fun of for this, and I'm all about it. But this was in my fridge, and I'm not sure if you'll be able to read this or not.
That's getting chroma keyed.
Okay. Yeah. Right. It's Bud Light Seltzer Classic Lime Margarita flavor. Happy Cinco de Mayo.
Who are sponsoring the stream today.
Right.
Just kidding. Why? Bud Light Margarita. I like it.
It's actually not terrible. I am not a seltzer fan at all, whether it's alcoholic seltzers or not, but this is actually palatable, and it's only 100 calories. So there's that.
Perfect. Dr. WD40 said they're unsubbing to you, so sorry.
He's subbed for like 24 months or something, so yeah, that's a
Hamsterlicious, thank you for the 100 bits. Threat. And yes, hooray for crazy flavor margs in a can. Welcome to Ask a Scientist Gaming, where you get the unique combination of Bud Light Margarita plus Kirbys Avalanche plus atmospheric chemistry. So nowhere else but here will you see that combination of unique things. All right. Triboluminescent wants to know, what's the highest life on Earth? Highest as in highest up in the atmosphere.
Oh, God. Man. I don't know. I mean, so here's the thing. Like, you have air currents that, can lift very light things way up into the atmosphere. So I guess it's a microbe that was randomly lifted way up in the atmosphere. Or, technically the atmosphere goes on forever. It's not like it ends. It's just like a density that is changing. So you could say the furthest out human at any point in time, or if there's, the furthest out human at any point in time would be the furthest living thing that's out. But it's probably some microbe that is, been carried up with air currents up in the atmosphere and manages to survive for some amount of time before it burns up and gets like destroyed by the UV light.
That is kind of fun, though. The answer is humans right now, presumably, right? As far as we know. That's
right.
That's a fun twist on that question. All right, so I'm going to throw... Ninja Physics Dr. Melko, do you know which subcommittee that your senator participates in? That will definitely color the science policy you review. Ninja Physics is a policy junkie, so probably have several questions.
Yeah, that's good. I love talking about this. When I get there in August, I do like interviews for 2 weeks. There's a certain number of senators that will be looking for science policy fellows, mostly Democrats, it turns out. And so I will interview with a bunch of different Democratic senators, and I get some sort of say over who I want to join. So part of my preparation process is going through all the Democratic senators and figuring out what committees they're on, and which ones align with sort of my interest areas. And they tell you, and I certainly expect that I'll be working on a bunch of different things. It's not just going to be like atmospheric chemistry, right? The day-to-day is different, so it just kind of depends. But I'm trying to narrow my search of where I might end up to people on energy committees or space, these sorts of things. So, I guess I would turn the question back around and say, I will be deciding who I work with based on what committees they are on.
Makes sense. And that's a 1-year fellowship? So
yeah, 1 year.
Yep. August till August. Okay. That's going to be fun.
Yep. So August till August, and then its sabbatical will be over.
So I don't know if I told you this, but I did a congressional briefing 3 or 4 years ago. And so it was,
really?
The Science Coalition, which is a lobbying group for science advocacy, they did this 2035 news story is what they called it. And they basically asked a bunch of people to write stories about what life will be like in 2035 based on their area of expertise. And so I'd done a bunch of blog posts, so I did a post for them, and I wrote, about, automated cars driving around, charging themselves, solar stations. We don't have to worry about roads as much and parking lots and all sorts of stuff. But because of that blog post, I got invited to DC to do a congressional briefing for the House and the Senate. And it wasn't like C-SPAN level or anything like that. But it was like me and 4 other people on a panel just talking to, I doubt any, House or Congress members showed up, but it was like all their advisors and people like you would have been there. But yeah, that was it was a weird experience because meeting politicians at that level in person is a different game because they are so socially savvy. Like everything you say to them, it feels like it's the most interesting thing ever said to anyone because they're just like super engaged and eye contact and active listening and all sorts of like how to win friends and influence people in action. It was something else. So like your interview,
I need to learn that stuff because
I really want to hear how your interviews go because it's crazy like how good they are at that. Like their skill set is just amazing.
Right.
So yeah, that was a hell of an experience.
Yeah. I don't imagine that it's going to be like the senator themselves interviewing me, but even like their chief of staff or their legislative assistant is going to have those same qualities, right?
Yeah. No, and it selects for that personality type, right? Like that is their primary skill set. And it's, I don't know, I wouldn't say discomforting, but it's like, American Psycho kind of Bateman type, like where does the needle point on the psychopath scale? Is it slightly below or above that? And are you a good psychopath or a bad one? Needless to say, I really look forward to hearing your experience because you are going to have an insane amount of stories from that.
Yeah, I'm really looking forward to it. Part of it's set up to be for people that have zero experience, and so there's like a week or two of professional development at the beginning where they like try to teach you all the stuff you need to know, and they just assume you know nothing about science policy, and that's like perfect because I really don't, other than what I'm trying to learn before I get there. So the hope and the agreement with the university that I get sabbatical from is that I come back and teach a course on science policy using all the professional development stuff I'll do and the year to sort of learn what it means and develop a course on it. So, I don't, maybe at your university, but at our university, and certainly when I went to school, we got zero, class or even in any class, anything about science policy, either as a career or just in general. So to teach a class with it, maybe team teach it with somebody in political science, I think would be really cool.
Yeah, I think we're fundamentally lacking science policy, ethics, and soft skills. Like all the things you need after you graduate school. That's something, we definitely.
Yeah, it's just hard to fit them into the curriculum, right? When you have like these certifying agencies that are like, you need to cover, these X courses, and your university wants all the graduates out in a certain number of credit hours. It's just, you can't find the space.
Yeah. Not only that, but students in the audience. Josh and I have no formal training on being teachers. We just kind of make it up as we go.
Yeah. Isn't
Cheers
that crazy?
to that.
That was, yeah. Really, I like TA'd a couple things in grad school, but like, I don't really consider that the same as what I do now, like, at all. Learn as you go.
Yeah, exactly. Ninja Physics, you read all the things forever and do lots of writing when it comes to policy.
Yeah.
Sounds like your next year is going to be amazing.
Sounds miserable. But I mean, you still write up, what is your day-to-day like, Ken?
Yeah, no, that's true. That's all I do is
Reading a whole bunch
write.
of stuff. And
I literally edited a paper for 8 hours today. That was my job.
Sweet job. But that's, what we sign up for to some degree.
Oh man, we did not choose an outcome on our which can hold breath longer. All right, what's the answer, Josh? Sloths or dolphins?
The answer is sloths.
Sloths can hold their breath longer. Sorry for holding up the prediction. I know you guys wanted your imaginary internet points. The answer is sloths, which can hold its breath longer.
Yeah, hopefully none of you were holding your breath for that answer. Yeah, it's crazy, but like their metabolism slows down so much. It's like hibernation. They can basically hibernate, so they can hold their breath for something like an hour or two, where dolphins are like, I think 15 minutes or something like that. So it's actually not even that close.
That is
sloths
a fun
in a
kinetics
landslide. Yeah, exactly.
So 5 people guessed sloths, 3 people guessed dolphins. Again, congratulations on those of you that picked sloths. Oh, penguin socks. That's one of my former students. Actually, my first graduate student is in the chat. She's gone on to bigger and better things.
Nice.
Yeah, that's crazy. Time flies. How long have you've been there since 2014? Is that right?
2014, yeah.
Yeah, mine was 2013.
6 years. All right, this will be the last go. If I don't beat him this time, then we'll switch to a different game.
Sounds good. Should we put bets on this one?
We could
do you want
poll.
That pressure? All right.
No, but maybe we could do a poll for what game they want to see next.
Ooh.
Do we want Mario Kart or Killer Instinct?
Mario Kart or Killer Instinct?
I think it's just /poll.
We'll set that up. I don't think I've done a poll in a while. I don't even have that on my hotkeys right now. Mario Kart.
Maybe you just type /poll, and then it should work, I think.
Sorry guys, I'm figuring this out as I go.
This is not going so well. Shocker, I know.
Alright, you said Mario Kart. That is the NES version?
Yeah.
Or the Super NES, sorry. Mario Kart.
Super Nintendo.
Alright. Next game, Killer Instinct or Mario Kart. Poll is open now. You guys get to vote on which game. After Monday's stream, I wouldn't go to Professor Melko for streaming tech helps. Something happened on Monday?
It was like, what did happen Monday? Yeah, something definitely happened Monday. I was having trouble. Oh, I was doing a fundraiser. Yeah, and so I was trying to sync up Tiltify, which is like how you fundraise on Twitch. Anyways, look, in the end, we raised $500. I did figure it out after 45 minutes. We raised $500 for British Red Cross to send PPE to India. So, yeah, make fun of me all you want. We actually did something decent.
No, well done, sir. So, yeah, give him a hard time, but he's doing good things.
I know.
Overlay flashbacks.
Yeah, exactly. It was
It's even harder
awkward
to do under pressure when you're on stream, because moments of silence feel like a lifetime. It's just super uncomfortable.
Yeah, no doubt. No doubt, yeah. Oh, I was supposed to switch games, right? Well.
The poll is not closed yet, but Mario Kart is winning.
Okay.
Both excellent games. All right, anyone just joining us, this is Ask a Scientist Gaming, mediocre gameplay, expert level science. Our guest today is Professor Josh Melko. He's an expert in atmospheric chemistry and science policy, and he's happy to answer any questions you have regarding any of those topics, science in general, chemistry, his thoughts on love life and the pursuit of happiness, whatever it may be, we are happy to answer here. Does the atmosphere have a pH?
Wow, yes.
What is the pH?
No follow-up questions. I'm sorry, at this time I'm not available for follow-ups.
Yes.
Yeah, it would be acidic for sure, but so 5? We're gonna go with.
I mean, no, it'd be tiny, right? Because it's moles of H plus per volume, and the concentration's already really low. I don't know. That's crazy.
Yeah, but I mean it's. Yeah, I guess. I'm trying to think about how much OH there is, but yeah, it'd be a lot more H plus, especially high up in the atmosphere. Yeah. Especially high up in the atmosphere, the pH would be, really tiny.
That's fun. Our atmosphere has a pH gradient. So if you just drop like phenolphthalein from space, you just see a rainbow.
Switch games here.
Yep, so Mario Kart 1. 6 votes for Mario Kart 1 for Killer Instinct. Sorry, whoever voted for Killer Instinct. We're going with Mario Kart. And I'm glad you remembered the volume change.
Yeah, but it's concentration, right? So it's so. That's actually a really fun question. It'd be negative log of the concentration, but the concentration would be so low of H plus just because it's, so thin.
Yeah. Like in the Ka of the acids would be the same, but the concentration is low, so percent ionization matters, and yeah.
Right.
All right, any Gen Chem students in the audience, beware. I guess you're not teaching this year, so we'll wait till next year.
Right.
Ooh, Ninja Physics. Does the acidity of the atmosphere have any bearing on the ocean's pH?
Well, I'll say this. The carbon dioxide in the atmosphere does acidify the ocean. So it's not like I think of the pH, or acidity of the atmosphere, but when that carbon dioxide goes into the oceans, it combines with water to make carbonic acid. And so the pH of the oceans drops. And then, there's this equilibrium shift in things like corals, whose exoskeleton is calcium carbonate. Because there's less carbonate in the ocean water, their solid calcium carbonate fills that void. Basically, the carbonate from their shells just sloughs off into the ocean due to the ocean acidification. So CO2 from the atmosphere goes in and lowers the pH.
Pause before you start playing. Can you pause? All right.
Yes.
So we're going to do a prediction on this, right? So no one has seen you play Mario Kart before, but you're doing a 100cc Mushroom Cup, is that right?
100cc Mushroom Cup, yeah.
All right, so the prediction is, will Josh get 2 wins in a row in the 100cc Mushroom Cup? So this is 5 races in the entire cup. And the question is, will he get 2 wins in a row? This is 100cc, so this is, I guess, medium difficulty. It's not the hardest, it's not the easiest, it's somewhere in between. Make your predictions now. Skeptics or believers? Is Josh going to get 2 wins in a row?
Pacific Plankton, welcome in. Good to see you. Pacific Plankton's another streamer. We were talking about open set and microscopy earlier. Pacific Plankton does California, San Francisco area, right? I think doing microscopy, looking at all the little awesome chaos and living creatures in the ocean water, in the plankton, as it were.
So it's not just a clever
in the Pacific.
name. That is perfect. Pacific Plankton, welcome to Ask a Scientist Gaming, and throw your questions in chat. Anything you want to quiz our guest on, feel free to throw them in chat now. How much
has the pH changed over the decades in the ocean water? I guess I don't know much. Like probably a couple decimal places it's dropped.
I mean, that's interesting.
But remember, it's a logarithmic scale, so that's a lot.
It has to be region dependent too. I mean, with the temperatures,
so region dependent,
flow rates, and
not just because of the temperature, but also the CO2, right? It's like, was it Henry's law? Partial pressure of CO2 above affects the solubility of the gas. So like wherever the CO2 is the most, then locally it's going into the ocean more there, and the pH will be lower there. Yeah. So I wonder if you could actually see a change in, like, you know, some factories in China that are putting out just massive amounts of CO2, and locally around some ocean close to there or other bodies of water, if the pH was markedly different. But I mean, it has so much to do with like soil chemistry too. It's probably tough to delineate what the causing factor is.
All right, prediction is closed.
The ocean is a whole buffered system.
Prediction is closed. We have 6 for yes and 3 for no.
Wow, you guys have way too much confidence in me. Okay, here we go.
You guys did see him play Kirbys Avalanche.
Just restarted.
Sounds good. Wait, did you lose a continue with that? I guess it doesn't really matter.
Yeah, but oh my gosh, this is way looser? Is that the term? This is way looser than I remember. Can you power slide in this one?
Yeah, the trigger bumper things.
Is that what I just did?
Yep, that little hop.
Don't you go like back and forth? Oh god. Oh yeah, the yeses are definitely gonna get it. Like, this game's too easy. We got this.
We got confidence here. When was the last time you played this game?
Oh god. I would say a decade.
Cog Psych Professor rating with a party of 2. Cog Psych Professor, welcome.
Hey, what's up, buddy?
And that is an awesome emote.
No!
It's the heart with a brain in it. I like it. Welcome to the stream. It's Dr. Swan, apparently.
He's a cognitive psychology professor.
Welcome to the stream.
Some classes, office hours. The other day we were watching a movie in his stream as part of what's that feature called? I forget. Anyways, he was like psychoanalyzing it on the fly. It was really cool.
That's fun. That's really fun. Welcome to the stream. Again, if you have questions for Josh, throw them in chat. This is Ask a Scientist Gaming, where we combine mediocre gameplay with expert level science, although the victory in that round suggests it's not so mediocre gameplay. We have expert level gameplay.
I had to redeem myself after that Kirbys Avalanche debacle.
I don't know. You went pretty far. Oh, it's called the Twitch Watch Party. So that's kind of fun.
Watch party, yeah, okay.
All right, so I have a question for you. What is the biggest mistake or accident you've seen in lab? Or caused in lab? We can go either way.
Oh, man. Okay, so most people will know what this... I don't know if people know what this is or not, probably not, but in vacuum science, which is to say when you're like... you don't want all the molecules in the air to get in the way of the chemistry you want to study, so you get rid of all that by pumping it all out and creating a vacuum. But you want to measure the pressure in your instrument, so you know how much air is in there. Anyways, one of the ways you measure the pressure, oh no. One of the ways you measure the pressure, oh my god. Let me try this a third time. One of the ways you measure the pressure in your instrument is through this gauge called an ion gauge. And basically what it is a glass shell with a little filament in it like a light bulb. And that light bulb shoots off electrons and ionizes gas, and there's like this currents measured that tells you how much gas there is. Anyways, all you really need to know for the story is that there's a glass like sitting attached to the instrument, and inside that instrument and inside that gas is high vacuum. And if that vacuum gets destroyed, you could damage a lot of stuff in your instrument. So it's important to maintain the vacuum. But the glass is delicate. So what happened in lab was somebody stood up and sheared off the glass. And as soon as it's sheared off, it means that all the stuff in the instrument can get damaged because outside gas rushes in and destroys the stuff inside. So basically somebody stood up, the glass cracked, and the first thing they could think to do was to cover it up with their hand. Yeah, and it's sharp glass, which sucks. And so they shoved their hand on there, which instantly bled, but the blood instantly solidified and froze because of the low pressure inside. It was wicked awesome. And yeah, it was really cool, not recommended. And he did probably save like tens of thousands of dollars in like electronics, because as we were talking about earlier, when you have like high voltages and the pressure changes, you can get arc like lightning that destroys the electronics. So, you know, that was the first thing he thought to do, and I think it worked. So that was pretty rad.
Worth it. How many stitches was that?
I don't think it was stitches at all, actually, but that's mostly because he didn't believe in stitches.
Just rub some dirt on it. It'll be fine.
Exactly. Man, electrical tape.
That's amazing. I mean, so our oceanographer had shark attacks, but I like this one. This one is saving the instrument, sacrificing your own health and well-being.
That's right.
I like it. Well, so a follow-up on that. What's the most expensive mistake you've seen?
I mean, this is really dumb, but yeah, I've definitely, like, 2 years ago in my own lab right now, I like turned a laser on before it was properly chilled, and we still don't know what happened, but we smelled ozone immediately. Something burned up. We think capacitors blew, and we spent COVID shut us down, but basically we've spent over a year troubleshooting, repairing. And I should say we really haven't spent all that time because of COVID. It's just that was the last time it was operational was over a year ago. And I don't know at this point how much it's going to cost, but yeah, that wasn't good. I haven't really seen anything worse than that though, or done anything worse than that myself. But you know, these lasers can be new, very, very expensive. This was an old laser, but even old, you know, 20, 30,000, something like that. I don't know. I don't have a great story about some huge piece of instrumentation dying, which is a good thing, I guess.
Yeah, no worries. We don't expect dollar amounts, but yeah, lasers are expensive. So if I'm not mistaken, you've won every race so far. So I think the prediction is already...
Yeah.
All right, 2 wins in a row in 100cc Mushroom Cup. The answer is a definitive yes.
Nice.
So
Adam, and welcome in. Good to see you.
Congratulations to everyone
is
that
this...
said.
Wait. Is there a way, I don't actually remember this, but at the start, can't you get I get this mixed up with like 64's Mario Kart, but can you get a boost at the beginning in this one by like...
Oh, by timing it correctly? Yes, I think when you hit
Yeah.
the accelerate when the green goes.
Okay.
Tribal Luminescence wants
Gotcha.
to know, how do you motivate your students?
passion, I think, goes a long way. Being excited about it in the classroom, I think, does help. You know, the cynic in me a lot of times just says you can lead a horse to water, but you can't make them drink. Because, you know, the students I seem to remember, you know, investing the most time in, often it's because they, like, weren't really doing things they should be doing. And so, like, it doesn't pay off, unfortunately, as sad as that is to say. And then there's, of course, other ones that, you know, you motivate and you can be the difference for them. And that's awesome. But I think just teaching with passion goes a long, long way, being excited about a subject. And I guess I'm mostly thinking about the lower level, like general chemistry, right? When they come into general chemistry, they're like, oh God, chemistry, this is so boring. And as long as you're excited about it, I think that goes a long way. Yeah, I mean, fear is also a great motivator, but I try not to teach with fear too much.
It's very Machiavellian of you.
Yeah.
Benevolence or fear. Either way, it's fine. All right, penguin sock.
Motivation is tough.
Yeah.
Because it's so, like, dependent on the person, right? Like, what are they really struggling with? Sometimes, if they're willing to come to office hours or something, you know, I will devote all the time to helping them with what they need. But if they're not, like, willing to meet me halfway, it's easy to, you know, when you're teaching 300 students, it's easy to lose motivation to help them find motivation, as sad as that sounds. But the ones that put in a little bit of effort, it is really worth it to help them and try to make a difference for them, whether it's just like studying a little differently or helping them make a schedule of like their times and activities. That can go a long way as well.
Natty science. My advisor actually does buy a spear. That helps sometimes, as long as they're above age.
That's a good advisor. I mean, in grad school, I don't think that we ever got that. Although I guess he would take us out to lunch and stuff.
That's fun. Penguin Socks has redeemed request a factoid. Do you have a factoid? Drop some knowledge bombs on our chat.
A factoid, yeah. So I am, you can't tell since I'm sitting down, but I am pretty tall, and I'm exactly one NASA spacesuit tall. So there's a height requirement, although with SpaceX it's a little different these days, right? But with NASA, I'm exactly one NASA spacesuit tall. Okay, because if I were any taller, I couldn't be an astronaut. So I'm definitely only one NASA spacesuit tall.
So what is
no taller?
What is their height range? Their acceptable range?
6'4". They're 6'3". I should know this, but 6'3".
Do they have a lower height limit too? Presumably, yes.
They do, because they only make the spacesuits so big, right? So yeah. And I did apply. It's now. Is it 2 years now? I guess it is with the pandemic. So they had an astronaut call 2 years ago. I applied. I actually applied on stream partly. And then
That's awesome.
We got past the first stage. We got past the second stage. And the first stage is really kind of trivial. It's just like, do you meet all the requirements? And the second stage is you write some stuff and you get past that. And then you have to take like 3 tests or something online, and then we never heard anything after that. So they did delay like about a year to hire the new class of astronauts, and I still haven't heard anything. So no news is good news, I suppose. We're still in the running for NASA astronaut, but yeah, we'll see. We'll see.
That is crazy. I mean, if Mario Kart is a qualification, you have clearly nailed it. That was 5 firsts in a row, wasn't it?
Yeah, man, that was...
Well done.
That was nice.
You crushed it.
I'll give you another bonus factoid. On this screen, usually you see like Toadstool has a like beer bottle there. It just looks like a bottle. But in the Japanese version, it is like a champagne bottle, and they actually drink it. Huh. And Peach, when she drinks it, she gets like flushed in the face and turns pink. It's really, really funny. But the American version, whenever this was made, like we couldn't show drinking in video games. There was some law against it, right, or legislation against it. So that's one of the few things that changed from the Japanese version of Super Mario Kart to the American version is they changed this last scene. So there was still a bottle, but they just wouldn't make the drinking motion, and that was good enough for the powers that be.
Man, I could have sent you the Japanese version of this. We could have compared and contrasted.
Really?
Yeah, I have it.
How do you get to the 150cc? Wasn't there 150?
I think you have to clear 100cc. You have to win gold.
Oh, like all of them?
I don't know about all of them.
Oh, just the hard. Okay, well, let's go to the hardest one then.
Rainbow Road, are you ready for this?
I can't do special. You can see I played this one and got silver before.
Yeah, that's not bad.
So I have to get gold and all just to get to the special cup?
I don't remember the rules behind it. Natty Science wants to know, when and why did you guys decide you wanted to be professors? So we'll start with you, Josh. When and why?
When, I would say, really not until, like, probably the 4th year of graduate school. I was still, like, pretty split between industry and academia. Right, it was definitely a possibility. Like, oh no. I went to graduate school, not really sure what I wanted to do with my life. Just loved to learn and wanted to keep learning. And then, in graduate school, I think it just appealed to me to be a professor because I wanted to sort of have some control in what I was studying, what I was doing. Plus, the little I did get to teach in grad school, I did absolutely love. And I knew I wanted to teach more. I didn't want to just teach. I still wanted to do research, but yeah, I think probably the 3rd year of grad school is when I decided I wanted to be a professor. What about you, Ken?
I don't know, it was early on, so I didn't realize I wanted to be a chemist until like 3rd year of undergrad. I changed majors 4 times till I landed on chemistry. So athletic training to exercise science to biomedical science to chemistry. And then I fell in love.
Wow.
And then I learned you got paid to go to grad school in chemistry. So any undergraduates in chat, go to grad school in physics, chemistry, biology, engineering. They pay you to go to those programs and get a PhD. And so
it's not like med school.
Yeah, exactly. No, they pay you. I mean, sure, it's minimum wage, but you're also not paying for classes and things like that. So it's worth it for at least most of us. It's worth it. But at some point during grad school, I like you said, I fell in love with teaching. I'd spent a lot of time mentoring and things like that as like I taught karate for a number of years and things like that. So it seemed like a natural transition to be an educator. But I also fell in love with my own ideas. And the only way I get to pursue my own ideas is as a professor. So that was a clear-cut case for me. Like, you sacrifice pay to become a professor, but it's worth it because of the flexibility and freedom you get both intellectually and scientifically. So it's a lot of fun.
Freedom is huge. I mean, the pay ain't nearly as good as industry, but yeah.
I mean, with that said,
put a price on freedom.
We're comfortable. Like, it's not bad pay. It's just it's not. My students who may be in chat make more money than me after graduating, and it's something. Yeah, there's certain trade-offs when you go industry versus academia.
Right.
But make no mistake, I love what I do. I really enjoy it. Being a professor, mentoring students, teaching classes. Sometimes it's a love-hate relationship.
Yeah, for sure. I mean, it's the grass is always greener kind of thing, but I would say not really in my case. I think early on, especially like year 1 was tough and a blur as a new professor, but year 2 was also really tough because I was still developing new courses and trying to get my research program off the ground. And I was just like, I don't know, it was a lot. And, the pay wasn't great. And, there were times when I thought, sure, seeing my buddies from grad school work in industry and make really high salaries, and not be super stressed out and killing themselves over their research. There were times when I thought I made a mistake, but I think that's just natural, and part of any job is you're going to have those moments where it seems like the grass is greener, but coming out the other side, like, zero regrets, no regrets. I love what I do, and yeah, I can't imagine doing anything different.
Yeah, something I wouldn't trade for anything. Like the graduate students in my group, when they start hitting like, third and fourth year, when they're truly independent and they transition from like a student to a colleague, like there is nothing that replaces that feeling. Like the growth and development transition is absolutely amazing. So yeah, Jamie, if you're still in chat, shout out to Jamie Wong. First grad student. Yeah, her and Sean were the cohort that really opened my eyes to like that mentoring progression. That's just amazing. All right, so mildly related, what was your I made it moment as a scientist? Like imposter syndrome is a very real thing, but there's also moments of glorious, just like someone cares that I'm a scientist, I have an opinion that matters.
Right. Yeah, the one that comes to mind is when it actually wasn't until postdoc, and some of our measurements actually started to be used in climate models on Mars, and I should say just atmospheric models, not necessarily climate models, but all my career we've been doing really, really fundamental research, which is like measure how fast A and B react, and like it goes into a table in some database somewhere, right? But those tables and databases are used in models of atmospheres, and the fact that our understanding of Mars's atmosphere and the fact that we're going to put people on Mars in the next decade and rely on the atmospheric chemistry and the understanding of that chemistry, and one number I measured is part of the model and a data input into that. That was really, really awesome to me, to have something I measured find real practical use, and not just any real use, but in something I've always been obsessed with Mars. So that was just so cool to me.
That's amazing.
Have that happen.
Like because
it can be very, and I don't know if you experience this too, Ken, but it can be very, like, depending on what you do, very fundamental. And part of the reason I'm going into science policy for a year is the timing's right, and I need to do some professional development, sure, but why I chose this in particular is like, there's huge direct consequences of decisions made in Washington, D.C. Like there's no way it's not. Whereas in the laboratory, a lot of times I can feel like, even if this experiment works perfectly and I publish a paper, just like, I don't know, gets cited a few times by me, and that's it, and nobody ever reads the thing, And so, like, it can be, kind of sad in some respect, but so that's why, like, oh no.
Yeah, no, I definitely
that was a big moment for
that.
me to have our data used.
I definitely feel it, especially in the solar cell game, where we just oversell the shit out of our research, like we're going to solve the energy crisis, when in all reality, 98% of academic research into solar cells will never make it into a commercially viable solar cell. They might add insights that someone will accidentally use 50 years from now for something useful, but like the direct application is very subtle. And like, we'll keep doing it, we'll keep grinding, we'll keep learning new things, but yeah, in terms of translation to real world, it's just not there.
Yeah, I mean, I don't think that number is unique. 98% never making it into commercial. Like, that's probably a pretty normal number.
Yeah.
And, out of all the papers I've done, like 2 or 3, maybe? Really that one, for sure. But maybe other than that, like, maybe I mean, there are numbers in databases and books somewhere, but how many are being actively used in something? A handful.
But I will say, my made it as a scientist moment is in grad school. I came up with an explanation. So usually when you extend the conjugation, a system, it redshifts, right? The particle in the box, you extend the box, it goes to lower energy. But I found an example where it would actually redshift or blue shift depending on where you benzannulate, where you extend the conjugation. And so it's a very simple orbital argument. It ended up being a Jack's paper, but in literature now is Hansen's rules. Yes, and it's been used once, and it was used by my graduate advisor and his PhD senior scientist. But Hansen rules does exist, yes, in literature. That's my moment.
That's cool.
Yeah, it'll never be quoted as such again, but it is in one paper, so it counts.
That's
Hansen's
awesome.
rule.
Yeah, that's really, really neat. And like I will never have a rule named after me. Dang, that's amazing.
But that one, and it's true, is I was working on like near IR photo detectors and solar cells and accidentally saw something weird and then explained it. And that's arguably the most impactful thing from my graduate experience. Even though we made prototype, screens for near IR goggles that may or may not be used, that is arguably less impactful than, just a new concept or rule. So, yeah. It's those moments that we take with us after failing for several years. It's the small victories. All right.
Peaches. And in the way here.
No.
Oh, no.
That one deserves a Vannucci rage.
I was sure I was holding backwards. I was trying to fire it back, with the green turtle shell, and that just did not happen.
You can drop it. That's right, if you press down. Yeah.
This is where the streak of first place might end.
And you are utilizing the power slide in the bumper. Veteran move here. Veteran move, ladies and gentlemen. All right, it's almost 10 o'clock. We've been at it for almost 2 hours. Anyone just joining us, this is Ask a Scientist Gaming, mediocre gameplay, expert level science. My guest today is Professor Josh Melko, expert in atmospheric chemistry, likes to think about atmospheres of Earth and Mars, not Jupiter. But he also likes to talk about science policy. He will be a science policy advisor starting in August in Washington, D.C. So he's happy to answer any questions, comments you have. Go ahead and throw them in chat. That was close, though. Second, you're still on track.
Yeah.
Actually, is that it?
I didn't even look at the timestamp.
It's 4 races, and is it?
I don't know. I have no idea. Oh, yep, you're right. So there's the bottle. So usually, once the trophy comes down, they'll start drinking it. But instead, a vine grows out of it.
Yeah, I mean, we don't want our kids picking up drinking from video games, because we know that's causal.
Yeah.
Oh, man.
Toad is not 21.
Toad is like 40. Yeah, I was going to say. Are we talking canon Toad from the original Mario Brothers? Toad is at least 35. Triboluminescence has a question on science policy. Besides funding science and regulating pharmaceutical approvals, what does science policy do?
Yeah, actually funding science is a huge part of it, so that's absolutely true. But, oh, shoot. I mean, anything that there's a scientific aspect to, you would hope that a scientist is in the room to give some opinion on. Right, so, any regulations by the EPA, Biden's new huge infrastructure plan, a lot of that has climate resiliency built into it. By resiliency, I mean, we've already done a lot of damage to the Earth, and we know that there's going to be terrible storms the next couple decades and longer. There's going to be sea level rise. So when you put in all this infrastructure that is part of this plan that Biden just is suggesting, you want to make sure you build into that the sea level rises over the next 30, 50 years, right? So that you don't have to rip up and redo the architecture or infrastructure in like a decade. Right? So that's climate resiliency. So you need scientists to suggest what are the best ways to, invest in making sure our infrastructure is going to last not just 20 years, but 50 years, considering how much the sea level is going to rise. And this is just the first thing that comes to mind because I've been thinking about it lately. But anything they're legislating to deciding how to spend money, how much money does the CDC get? How many ventilators should our national supply have, in case of a pandemic? These are all things, the past couple of decades, something we've cut corners on that, early on in the pandemic really led to a lot of casualties. Not to sugarcoat it, but it was in the Obama era, there were scientists suggesting, and we did start to beef up our ventilator supply. The problem is, at some point, the people that were making the ventilators, somebody in Congress earmarked money that didn't go to those ventilators, and they got bought out by another company who decided the ventilator contract wasn't worth their time. And this happens all the time with scientific agencies, right? Like, my laser company doesn't exist anymore, and I can't even get parts for it because the company doesn't exist because the company that bought them decided it wasn't worth their time to service them. So this happens across all industries, and so the ventilator supplies we had early on in the pandemic were few and far between because we did not invest in make sure we produced a bunch of ventilators and kept them up to snuff, basically. So there's all science policy is everywhere, although I would argue that there needs to be more scientists involved in the policy making decisions than there has been in the past.
I mean, there's a fundamental difference in the dialogue of a politician and a scientist, right? Because scientists, we are the experts in the area, but we will give so many qualifiers on the boundaries of our expertise as well as how sure we are about something when any random person on the street can say, I know this is true. And to the average, third-party viewer, it's so destructive to the dialogue because it's not even an honest conversation anymore.
Yeah, it's so frustrating, and this past year has really shown us, even like scientists like Fauci who have, an excellent scientific community, an excellent scientist, period. Fauci is, you look up his number of publications, God.
Yeah.
But like
his H index is like 250 or something. It's just
I know,
insane.
It's insane. But he's also an excellent scientific communicator, and he chooses his words very carefully. Mm-hmm. But even so, he has to say something sometimes that is, has an error bar to it, and some people think that error bar means that he doesn't know what he's talking about, or that it's quoting a number of deaths that we could have is just an alarmist, and he's just trying to be like an alarmist when really it's just part of the error bars and exponential growth, which people don't understand at all. It's just, it's sad. Certainly the pandemic re-encouraged me or further encouraged me to go into science policy because there's just so many failures, I feel like, the previous administration with regard to science in general, whether that's through EPA regulations or the pandemic.
Nice. Well done.
Dunning-Kruger, yeah. Oh, really, Ninja? That's really cool. I didn't know that.
Wow, that's interesting. All right. Detour from policy, triboluminescence. Are we going to keep getting more hurricanes every year?
Well, so I'll say this. The storms, there's year-to-year fluctuations, right? Like, will we have more hurricanes this hurricane season than last hurricane season? Maybe yes, maybe no, but, it's kind of like stock market, there's going to be ups and downs, but generally it goes up overall. You heard it here first. Stocks only go up. Not financial advice. To the moon, that's right. Come on, Doge. So like there are blips of up and downs, but generally the trend, is up. So yes, the general trend will be over the next several decades for there to be more frequent storms and more severe storms. And really, the worst part of that, and I think doesn't get enough attention, is flooding. We see it when it happens, but there's really such devastation from flooding, and such poor policy right now in terms of flood and flood insurance and where people can build. And we're in for a lot of sad climate disasters, especially with regard to flooding. I mean, Houston and Harvey was like, and we're just going to see that year after year.
And I saw a recent estimate. They said something like houses in flood regions are overvalued by like $50 billion because people just aren't accounting for it's hard to sell your house when it's in flood region.
Yeah, and these people, like these low-income families that live in flood zones, it's easy to say like, oh, just move.
Yeah,
who are you going to sell your house to when there's, you flooded 3 years in a row? And yes, insurance has helped you rebuild your house, but like nobody's buying that house if it's flooding every year.
And you have
so you're just stuck.
$200 worth of liquid funds to do anything with at any given time. Yeah, it's gonna go bad.
Yeah.
Harvey pushed the entire land region around Houston 3 centimeters down from the amount of rain it dumped on it.
Oh my God! I've never heard
changed the height of Earth. Wow. Ben Climate Change Shapiro, just move. Yeah, they're just going to sell their house.
Yeah, exactly.
That is an amazing quote. Anyone should go watch that if you can. All right, Hamsterlicious, I have not forgot about you. Hamsterlicious has redeemed Take a Drink. And said, I thought hurricane
Is this a special drink?
I think we should do a special drink. Who's up for a special drink? Cinco de Mayo, we are celebrating with tequila shots.
What kind do you have there?
So I have Herradura Silver, aged 45 days. I honestly don't know enough about tequila, but this is to celebrate.
I don't either, but that sounds much better than mine.
Well, at one point,
Hornitos?
I had a tenure, like I got tenure, and I had a party at my house for all my colleagues, and I literally looked up good sipping alcohols and then bought a bunch of them so I'd have them on the shelf. So this is
nice.
One of those. So yeah, it's probably good. The internet told me it was. So Michael Jordan's tequila.
When has the internet led you astray?
Exactly. We have approval from chat on our tequila. So,
oh yeah,
anyone
chat's
in
never
chat,
wrong either.
You should join us on this, celebrating both Cinco de Mayo and Ask a Scientist Gaming, and my guest joining me, Josh Melko. Josh, you want to do the cheers on this one?
What do you mean? Do I have to say something or just?
Yes. No pressure.
That's okay. First, thanks for having me on. But I'll just say, I'll keep it short and sweet and say, for science.
For science, ladies and gentlemen. Oh, man.
Not bad.
Yeah. That was smooth.
Not bad.
Oh, Hamsterlicious. 1,000 bits for science.
Wow.
Cheers. Thank you for... again, thank you for coming every single time. You guys make up our stream. We really love our audience and our regulars. Ninja Physics just wrote something in Spanish that I'm not even going to attempt to pronounce. Josh, if you have any...
I know Arriba.
Arriba, we'll leave it at that. Thank you, Ninja Physics, for the comments. Hamsterlicious, again, thank you for the bits. We really appreciate it. And thank you for the questions. Whew. This stream is just going to go downhill from here, though.
Yeah, I mean, you'll notice I've definitely gotten worse in Mario Kart as we we've continued here.
Is this is the last race?
I think so. And if we, well, I don't know if I have to get a certain place here to get the special cup. If you have to get all golds or what.
I honestly don't remember. I used to play battle mode in this game a lot. Like that was
me
my
too.
jam. I loved battle mode.
One day when we can be in person again and play battle mode, I think it'd be hard to do it remotely here.
Yeah, speaking of which, starting May 26th, we're going to start doing in-person Ask a Scientist with vaccinated guests. So I'm fully vaccinated. My wife is as well. So yeah, we're going to start in person. And we're going to try to do it every 2 weeks on Wednesday nights. So yeah, check out the calendar. Actually, I have a list somewhere here. Sorry, I'll let you focus on the game.
Oh, it's okay. Who's
So Wednesday, May
next?
26th, Dr. Scott Stagg, he's from Department of Biology at FSU. He does protein structures by cryo-electron microscopy. Then June 9th, we have Justin Kennemar, who does plastics, sustainable polymers, block copolymers, patterning, things like that. June 23rd, we have Dr. Hanwei Gao, who is a condensed matter physicist who does perovskite solar cells and LEDs, as well as spectroscopy. And then finally on July 7th, we have Don Carr, who's a sociologist who studies health and aging and like late life treatments and how people progress through late life in terms of treatments and healthcare and things like that. So yeah, broad swath of scientists. So yeah, doing this in person is so much easier than trying to do it remotely.
Yeah.
Well, with you it was relatively easy, but I've had to drop off computers and green screens for about 6 months now, so that's why we weren't doing it regularly. Yeah, but starting May 26th, we're going to do it every 2 weeks, so should be fun. Oh, that was stolen.
I don't know if we got the gold. I'm not sure. I think I needed to place there.
Natty Science asks, do you know Zakai Suo? No, I do not. Is that a professor at FSU?
Oh, Princess beat us. Yeah, I think Natty Science worked there or went there.
Yeah, I don't know who that is. By the way, in chat, if you guys know anyone that would be a good guest for Ask a Scientist Gaming, like send me an email or send them an email sharing the YouTube videos. Like, we're looking for, I'm trying to find a Venn diagram of people that are experts and professors in science and want to play video games. And that is a small subset of people that I can talk it into. So, yeah.
Gotcha, Natty.
Oh, Ohio State. Okay. But yeah, if you guys know anyone that would be a good guest or you think I should reach out to them, please send me an email. All right, sorry I missed it. So you're starting this one over? You're going for gold?
Yeah, I mean, there's nothing else to do unless we want to switch games.
It's up to you. It's 10-12. Maybe try one more?
Because if we get through this, then I'll have to do the special cup, and it'll be a whole thing. So let me switch. Donkey Kong Country Killer Instinct, I guess. Some of the best music. That might have been loud.
Yeah, it wasn't too bad. Sometimes it jumps, sometimes it doesn't. We have fallen behind on our predictions, so I'll pop a few of them up because it's 10-12 already. Time flies.
Yeah, I know, it really does. This is so fun. It's been a long time since I've
Who knew drinking and gaming was fun?
Yeah.
Man, it has been a long time since I've seen this game.
Ninja Physics, the swimming music, the underwater music in Donkey Kong, I think is one of the like best video game songs ever. I love that. Do we want to do a prediction?
Yes. All right, prediction is up.
What is it?
So the question is, which was an Olympic sport? Is it architecture or chess? It's presumably early Olympics. One of the two was an Olympic sport. Which one of the two was it? Schmonite and Uncle Bill there. I just put the July 7th as Don Carr. If you check out on our page under the About Us, there's a schedule section that lists all the people that'll be coming up. But starting May 26th, it's going to be every 2 weeks on Wednesday nights. So we're going to try to get much more of a consistent schedule going. And I will keep digging up people as we go. Which was what inspired this question?
Well, one, I was thinking about the Olympics because
Japan.
It's coming up like a couple months, right?
Yep.
And I was playing a lot of chess lately as well.
That's awesome. Yeah, so we had Street Fighter 2 from Steve Leonard last time. We've gone through the games. We need somebody to do Mortal Kombat next, and then we've hit all the iconic fighting games.
Really? Nobody's done Mortal Kombat?
Yet. And then the movie just came out, too. I don't know.
I know, that's what I guess I didn't think about that one. Did you see the video? Or the movie?
No, not yet.
Yeah, me neither.
Trailer looks fun. I don't know if they can beat the campiness of the original, but...
Yeah, from what I've heard, it was better than the original, but, I think that's because the original was, so bad it was good, kind of thing.
All right, so which was an Olympic sport, architecture or chess? We have 6 people guessing chess and 0 people guessing architecture. What is the answer?
It's closed? Oh, wow.
Yep.
So wait, what was the question?
which was an Olympic sport?
Architecture was an Olympic sport. Chess was not.
Architecture was an Olympic sport. No one got credit. Nobody went with the non-obvious answer on that one.
Yeah, I think it's really kind of funny, but early on, it was very much sport and art. So you had things like painting and architecture and things like that. Because, I don't know, back then it wasn't. It was like anybody that was best in the world and something, and art and sport was kind of an art. So yeah, it was architecture. They had sculpting, and that was part of the architecture category.
Architecture. Somebody got an Olympic gold in architecture, and it was passed on to their great-great-grandkids, and somebody's sitting with that medal somewhere right now, and nobody believes it.
Exactly right.
I can't remember. Does this game have any finishing moves or anything like that, or was that?
It does, but I don't know any of them, so it'd be. I don't know. No.
So it was like the county fair architecture blueberry pies decathlon.
Yeah, pretty much. Exactly right.
Exactly. That's pretty amazing. All right, back to the science. This may be an easy one. It may be a hard one. Some people wrestle with this. What is your favorite equation?
I mean, probably Schrodinger's equation, just because I'm a huge quantum nerd, and that's kind of like the equation. But he just combo breakered me. Either that or entropy increases, kind of the derivative of S is greater than or equal to 0. So I would say Schrodinger's equation, although entropy increases is pretty important.
So it's either fundamental quantum or second law of thermodynamics.
Yeah.
Turns out both of those things are important. So I can agree with either of those.
Oh no.
Yeah, natty science. Reminds me of the Dutch scientists that used aqua regia to dissolve their Nobel Prizes when the Germans invaded.
Yeah, crazy.
The Nobel Committee or Nobel people remade the medal afterwards. That's using your head. Better living through chemistry, even through a world war.
Speaking of that, Natty, the person that invented knock-knock jokes deserves a Nobel Prize. Knock-knock, Nobel? Okay.
You've captured the dad joke moment of the night.
Yeah. I thought Natty would appreciate that.
Yeah, no, that was an upper echelon dad joke. It's for the classy people that take shots.
I
While
have a dad joke redemption in my chat, so I have to always be prepared.
Oh, do you? That's awesome. Oh man, I have to think about that. Channel points for tell a joke. How many science jokes are out there? All right, everyone. Anyone joining us? Oh yeah, Dr. Hansen, when was the last time you had Val's? So in St. Cloud, there's a Val's Burger that's just this little corner burger shop. And it's like you walk up to the window and get a burger, even during the winter when it's super cold. They actually have an entry area, but it's a mainstay in St. Cloud, Minnesota, which is about 20,000 people. And I'm going to say the last time I had Val's was probably, I'm going to say 7 or 8 years ago. Somewhere around there. I don't make it back to St. Cloud too often, but when I do, I go to St. Cloud State and give a recruiting talk. So if I'm back there again, you'll probably find out about it through this. Yeah, I know it's too long. So it goes. I've also not lived in Minnesota for 16 years now. So I moved to LA for graduate school in 2005 and have not lived in Minnesota since.
I'm going to Minnesota in July. My in-laws live there, so we go every year. Oh my gosh, I just got destroyed.
Where are they?
The Twin Cities. So my wife went to a small college in the Twin Cities, and so we go there usually once a year, sometimes twice.
Did she go to Carleton?
No, St. Catherine's.
St. Catherine's,
and,
okay.
St. Paul, I think. But yeah, I love the Twin Cities. It's probably my favorite place in the United States, to be honest. Although I also like DC, which is good since I'm moving there. But yeah, especially in summer. I mean, we got married there. We got our reception was in the Science Museum of Minnesota.
Oh, that's awesome. I really love it. Was that the old Science Museum or that was the new one?
New, I suppose. I mean, it was 7 years ago now.
Okay.
Yeah, 7 years ago now. So it was new, but yeah, it was great. It's just there's so many places to bike, and like people are nice and generally like take care of their environment. So yeah, I was really looking forward to that. I've never been to St. Cloud though.
That's give or take. That was Michelle Bachmann's district. So
okay.
it's gerrymandered all up and down that strip, but yeah.
Yeah, and it's only gonna get more gerrymandered. Well, wait, who's the governor?
I don't know who the current governor is. Scuzzbot is from Minnesota, so they might be able to chime in.
Gerrymandering is up to governors, right?
Tim Walz. Hundreds of miles of biking and running trails.
Well, can you get a job with 3M, Natty? It's presumably they're headquartered there, right?
Yep.
Oh no, maybe not since you're in biochem. Hundreds of miles of biking and running trails. Yeah, I love it there. Nice.
On the other hand, it's cold as shit there. I mean, minus 40 degrees. Fun factoid: if you say something is minus 40, you don't have to specify Celsius or Fahrenheit because it is the same.
Exactly.
Not lately. Good point.
I love it.
Glacius is just wrecking you here.
Yeah, he is. And that move right there, I just have not figured out how to block. All right, take that. Glacius. See, I can't, like, no matter what, he wins that encounter. Oh no.
All right, so the tequila has set in sufficiently for both of us. So I'm going to go with this one. If you had unlimited resources and no moral qualms, what scientific experiment would you do?
Right. I think I would blow up the moon. and just see what happens.
Okay.
Just see what happens.
What's the testable hypothesis with that particular experiment? What does that do?
Our well, it completely destroys the tides, which affects obviously the oceans and everything else. But it also probably changes our orbit and like might throw off, our tilt, which changes our seasons. And so it's a longer game, but one I'm interested in playing. The other thing I might do is try to engineer humans for space environments. So is there a way to like make us more resilient to deep space environments? So, just mess around and see if certain characteristics are like better for the radiation environments of deep space. And we've already done sort of twin experiments with Mark Kelly, who's now a senator of Arizona. Dang it. He was part of the twin experiment where one of them went to space, one of them stayed here. They're identical twins, and they found like changes in DNA. But I think we could ramp that up and see if we could actually genetically engineer certain traits to make us more resilient to space environments.
I mean, so it's
Yeah, exactly,
mostly
Scuzz.
the particle bombardments, right? We don't have the electromagnetic shield of the Earth anymore, so get bombarded
Right.
with everything. And then the low gravity also damages us.
Yep, and Mars does, not have this liquid metal core that gives it a magnetic field like the Earth has. It does, people say Mars doesn't have a magnetic field, but it actually does. Just much, much, much weaker. So all these harmful particles from the sun actually get to the atmosphere and to the surface of Earth, or the surface of Mars. So what you would want to do is build something about, between the Earth and between the Mars and Sun to deflect all these harmful particles. So there's this. Whoa! I don't know what I just did, but that was cool. You put this huge magnet at something called the Lagrangian point between Mars and the Sun, and this magnet would deflect all the magnetic particles. The Earth doesn't have this problem because we have a magnetic field to deflect these high energy magnetic particles that the sun's spitting out. So that's pretty low stakes experiment, but I would also do that. Yeah, that's the main problem comes from the magnetic high energy solar particles.
Scudsbot, sorry I missed this. Scudsbot, thank you for the gift sub to Natty Science. Natty Science, enjoy your emotes. You get both ethanol and Venucci Rage. Two very useful emotes, particularly while playing fighting games. Natty Science has a question.
No, I do not, Natty.
Do you know of any atmospheric evidence for life on Mars, was the question, and the answer is no.
Yeah, like on Venus, right, we have this new thing, phosphine, that's supposed to be life on Venus, but it's not really true. It could be, but I don't see much evidence of it. No! Yes. Nothing like that on Mars yet. The only other thing that we have is water on Mars, so no atmospheric evidence. You can look at isotope ratios and whether those are affected based on some respiratory process of something that breathed or underwent some sort of respiration, but we haven't seen any of that yet. I mean, there's blips where we think there's like methane or methanol or something that might be coming from the like soil, but it's probably just like geothermal vent sort of stuff.
So that go ahead.
I was just gonna say, yeah, a while ago there was like this, this suggestion that there was like this methane coming from the surface of Mars, but it was like just bad data.
And so you had a very subtle but amazing, scientific observation in that comment about isotopic ratios of living things. Can you expand on that? Because it's amazing. It's how we try to find out, really old living things and ages of things and whether a particular spherical thing in a stone is life or not.
So, when light up in the atmosphere fractures apart nitrogen, you get nitrogen atoms. And it turns out that anyways, I don't want to go too much in the weeds. There's an atmospheric process that over long timescales basically gives you a steady state of carbon-14 in the atmosphere. And that carbon-14 makes its way into carbon dioxide. And that carbon dioxide is taken up by plants. And there's a certain ratio then of, due to nuclear chemistry in the atmosphere, there's a certain ratio of carbon-14 to carbon-12, these two different isotopes of carbon. And so if that's in the air, and then plants are taking up CO2, they will have this certain ratio of carbon-14 to carbon-12. And then if something like an animal eats that plant, the animal will have a certain ratio of carbon-14 to carbon-12. And what's great is that carbon-14 has a certain half-life where it decays to carbon-12. So if you pick up like a piece of a tree that just died, yesterday, it will have a certain ratio of carbon-14 because it was consuming this carbon-14 in the CO2. And if you find a really old branch, that's not living and consuming CO2 because it's been dead, well, it will still have some certain ratio of carbon-14 to carbon-12, but some of its carbon-14 has decayed. And so we can, figure out how old something is with carbon dating because of this decay process of carbon nuclei. When the thing's alive, it's consuming it and replenishing this carbon-14, but as soon as it's dead, it doesn't replenish this carbon-14 anymore. So, based on the ratio of carbon-14 to carbon-12, we can figure out how old something really is.
A fun additional factoid on that related to kinetics. Biological things process C12 faster than C14 typically. Because the heavier it is, the slower the reactions go, depending on the reaction. So there's a correction factor in there. And so that's how I learned that heavy water is actually toxic for you. And so D2O has an LD50 value.
Well, it would just mess with your hydrogen bonding a little bit, or subtly too, right?
Yeah, exactly. So heavy water, so H2O, it's just two hydrogens and an oxygen. D2O is basically hydrogen that's twice as heavy, right? And so if you make D2O and drink it, you essentially have heavier hydrogen in your body. And so that heavier hydrogen slows down every single reaction that involves hydrogen. And so there's an LD50 of heavy water that's something like 4 liters. Like if you were to drink 4 liters of D2O, it would actually kill you because it slows down your kinetics and messes up all your kinetic pathways.
Dang.
So yeah, don't drink D2O. At least not that much of it. So yeah, there isn't. Supposedly it's sweet. That's interesting. It tastes differently. That's... Man, I mean, drinking a milliliter of it won't do anything. But yeah, don't drink 4 liters. It's something like that. I don't remember what the exact value is, but yeah, drink enough, it slows down your kinetics to the point where you die.
That's crazy.
Yeah, fun factoids here on Ask a Scientist Gaming.
This is really dark. We've talked a lot about like global warming and how bad of a state of affairs we are, and drinking DTO is going to kill you. What uplifting thing can you share with us?
I have another dark factoid I learned about fairly recently, actually. So the cancer diagnosis rate from the age of 61 to 62, 62 to 63, 63 to 64 increases about 3% per year. This is in the United States. The cancer diagnosis rate from the age of 64 to 65 increases by 50%.
But how is that possible?
Oh, so the answer is not that cancer prevalence goes up at the age of 65. It's that Medicaid becomes active. So people are literally waiting until they get Medicaid in order to get medical treatments for cancer. So people are delaying their treatment for cancer that could kill them because they can't afford health care in the United States. So, yes. The American
Imagine living in a country where we provided health care for all our citizens.
I just...
Controversial.
I'm not going to rant on stream, but that is just crazy, right? Again, and we're well off, but we're like one major medical condition from losing our house, and it's just crazy. The system is so broken.
Yep.
But
it's America.
America. All right, so we got a prediction we're going to pop up at stream for those who are still around. All right. So the question is, who is older, Josh or me? So Josh, you don't actually know the answer to this one, but you posed this question. It's an interesting question.
It's got to be close. How do I vote in this?
It is close. Don't let the white hair deceive you. We don't know which way this one's going to go. My white hair is a style statement. It's a choice.
Yes, I dye mine white. To look more professorial.
Yeah, exactly. So yeah, this one's a pretty straightforward question. Who is older, me or Josh? I don't know what additional tools or insights. I guess somebody could look up our birthdays really quickly, or maybe our graduation dates, but...
Can you look up birthdays? I mean...
I don't know.
Yes.
The internet. You can look up anything. If you know the right keywords. What's your guess, Josh? Or maybe that'll bias the outcome. I'll wait till they're done submitting.
Yeah.
What a random question. I like it, though. Scuzzbot says, you can find many things on the internet. True. Natty Science says, I put all my points on Melko. The question was not who is more mature, it's who's older.
Oh. Dang it, I could have beat Fulgore there. This is the penultimate character.
Is it? This is the... I'm not familiar with Killer Instinct lore.
Like, there's only one more after this.
Do you get infinite
unless there's somebody... Actually, there might be somebody after that. I think so.
All right. You guys have about 10 seconds to put your guess in. Who is older? Ken or Josh? It's not necessarily one you can make an educated guess on. But we both know Super Mario Kart. Ooh, it's pretty lopsided on this one. You want to hear the statistics? So it's 3-3 on people guessing, but 30 points said Ken, 993 points said Josh.
Wow.
Josh,
I also think I am older.
You think you're older? When was your birthday?
July of 83.
I am May of 82. So the answer is Ken is older.
Really?
Yep. So I graduated high school in 2000. So you would have been 2001?
Yep, 2001.
Yeah. So we're both top end of the millennial chain, but holy crap, Cheap Scientist just got a 34-1 payout on their investment. Well done.
Dang.
Yeah, enjoy taking Natty's internet points, because that was a hell of a payout. Well done. 34-1. I don't think I've seen a payout that high. Congratulations to those of you that have guessed me. Question is, why did they guess you? I don't know what gave that influence. I guess they just spent more.
You have a very young looking face.
Is that it? The hair offsets the face. I like it. Turns out that was a really good question and a really big payoff for a few people. Turned 30 standard internet units into over 300, over 900. Well done.
I'm never going to beat this guy. This is the final boss. Dang.
I mean, you have 22 minutes till 11 o'clock. I will gladly hang out until then.
So there's a Scuzzbot and a Scuzzbot Who Dis?
Wotus, yes. Disclaimer, that's my brother and his wife. So Scuzzbot is actually the moderator for our stream.
Holy. I really need to learn some combo breakers to beat this guy.
Wow.
I don't know any.
That is a non-trivial fight. Your fake internet points down the drain. You can't request factoids or drinks anymore because you thought Josh was older. Tragedy of our time. Oh, I like it. All right, back to my questions. So what is the Earth is flat or anti-vax equivalent in your field? I guess a while ago it was CFCs. Is there anything now?
Chemtrails, but I'm not going to go into that.
Is that a real thing? Is there a sufficient body of people
No.
concerned about chemtrails?
No, is there for Flat Earth? There's a conference once a year for Flat Earth conspiracy theorists, but there's like 100 people there.
Yeah.
Actually, that's actually a decent size considering Gordon conferences are like 100 people.
Good point.
When you think about it.
Yeah. That's a non-trivial amount of flat earthers.
Right. I guess I would say the following. So this is maybe too technical, but something that comes to mind is like when people think about like how we usually teach plain like activation energy and like reactants going to products, they often think like there's some magical energy that like the reactants need to have, but people don't think about the thermal distribution and like all of the molecules and the range of energies that are available. And so there's always like theoretically some portion of molecules that are getting over and making products, although we usually sell it as like they don't have enough energy so it doesn't happen. So there's a lot of subtle chemistry, especially in the atmosphere, where like things are really energetic and the tail of the energetic distribution can actually lead to a lot of really interesting chemistry that can create new species that go on to make something else. So I think there's a lot of times, especially in kinetics, much focus on most of it doesn't happen, so we'll say none of it happens, when really you can have the tail of a thermal distribution. In other words, really, really high energy molecules that can get over this activation energy cause some subsequent chemistry that goes on to affect the atmosphere or the environment. So the other thing I'll say on that I think is really interesting is submerged barriers. So this is probably not something that many people are familiar with, but usually when we think about like reaction profiles and activation energy and stuff, nice, eat them. We think about like some barrier above, but it turns out that even if the reactants are above a like barrier, there is still an effect on the reaction. So, if you roll a marble down a hill, it's definitely getting over that hill, right? If the hill is downhill. But molecules can see that submerged, meaning less than their energy, submerged barrier, and actually turn around and go back the other way, even though you think they have enough energy to get over it. So it's getting a little technical, but the role of a barrier below the reactant energy is something that's glossed over too much, and people don't think it matters, but it really does.
Know what else is glossed over? The fact that you just beat him.
Yeah.
You took the win. Congratulations.
Thank you. TTU Geography. Welcome in, dude. Good to see you.
Yeah, thank you for the follow. S. Stagg, thank you for the follow as well. Presumably that's Scott Stagg, our May 26th guest for Ask a Scientist Gaming.
Oh, nice.
Scott, thanks for stopping by. Yeah, you missed out on the prediction question of whether Josh or I are older. And a 34-1 payout. I am the older one of the two. But yeah, congratulations. You just beat Killer Instinct. Is that taught in PChem? I only took biophysical chem. Definitely heard of that. I mean, that is underappreciated. Like, there's a distribution of energies within any system, and some of them are fast enough to do stuff. And if it's irreversible, eventually all of them do that stuff. There are grad students that don't fully grasp that concept, right? And you're right. It's like there's a threshold, but there's a distribution behavior. So, yeah.
Right.
Oh man, we got a long one from TTU Geography. If the second rule of thermodynamics is true and a natural system tends to a disordered state, how is life possible?
So the second law of thermodynamics says that entropy increases in a closed system. So if you think about the entire universe as a closed system, then entropy in the universe does always increase, right? But a living species within my body, there can be nice orderly arrangements like DNA, because I'm constantly interacting with the rest of my environment. So Gibbs free energy is this concept that balances entropy with enthalpy, which is really just energy. And so, you can have this nice ordered arrangement of, say, DNA in a double helix, and not all this just chaos and entropy, because, the human body is not this isolated system. You can have an energetic benefit that offsets the entropic price, such that overall it's still spontaneous and happens. So in the entire universe, entropy is always increasing, but that doesn't mean locally entropy can increase, because other places in the universe, or I should say through heat and other artifacts, the entropy overall in the universe will increase, even if locally the entropy decreases. And it's being offset through enthalpy considerations, and Gibbs free energy is really dictating what's happening there. So it's always about Gibbs.
Yeah, that's
and entropy, right? Natty science is something I harp on a lot, especially when I teach it. It's often taught as disorder, but it's really just statistics, right? Like, entropy is statistically, how our human brain categorizes things, and sees like all the molecules in the corner as being this nice ordered state, whereas the molecules are probably spread out through the room. It's just more statistically what's likely to happen, and we call it disorder, but that's really like a human construction of how we categorize order and disorder. What happens is statistically what's most likely to happen, and we call that entropy.
I have a diatribe about that when I teach general chemistry, because there's a lot of creationists that say second law of thermodynamics says evolution can't happen, and they're just fundamentally misunderstanding the border between system and surrounding, right? And it just doesn't. They don't know what the difference between those two is, and so the continuation, or the statement, is basically complex humans can't exist because entropy is increasing, but houses can't exist because entropy is increasing. It's just nonsensical, right? We can exist at the cost of entropy surrounding us, right?
Yep.
And I like to express that too. Like, me talking right now has increased the entropy of everything around me. I have affected the universe by simply existing and acting. And it's really underappreciated how those delta S's balance out.
Yep. Yeah, everything does. I mean, unless you'd like go down the physics rabbit hole of, is our universe closed, or are there multiple universes, and is there like information exchange between universes? But you probably need another scientist on your stream for that conversation.
I don't even know who would. I mean, that's going to epistemological arguments. Maybe a philosopher would do.
Yeah. No worries, TTU, but just you asking that question increased the entropy of the universe.
No, I wasn't judging. I have a couple I do an entire lecture, and it's too bad Bronco's still not at stream, but I do an entire lecture about emergent complexity. And like this phenomena, I argue one of the major breakthroughs in science in the future, like on the threshold of, quantum mechanics and, relativity, all these things that change the ways we think about the world, is someone coming up with an equation to describe emergent complexity. Not just will complexity arise, but these are the rules that make complexity arise. And so that's everything from the stock market to how our neurons interact, how ants make an anthill. That is all emergent complexity. So right. Localized entropy decreases at the cost of entropy everywhere else in the universe.
So is this related to just defining life as well as some emergent complexity? Because we really don't have an excellent definition on what defines life. I mean, I guess emergent complexity comes to mind, but yeah, we don't have a set of rules for really describing how that happens or why that happens.
Yeah, and that's one of those things, like, what I love about science is first we figure out something weird, then we explain something weird, and then we utilize something weird. And so imagine like utilizing emergent complexity, like intentionally making some series of events happen that assemble a structure or like heal tissue, or, you know, if you understand the nuance of it, can you actually control it? And so mark my words, that's going to be the next earth-shaking breakthrough in sciences, is somebody that really understands and explains emergent complexity.
Yeah, I think that would have pretty far-reaching ramifications. I mean, there's still, I get fascinated a lot, and like just thinking about how life started, you know, was it totally random? And, you know, is there other life out there? How random does it need to be? What are the set of conditions necessary? And, you know, you read about these old experiments where you could like just shake a bunch of certain chemicals together and you develop amino acids. Okay, that's great, but how do those amino acids then like know to get together to make proteins? And then how do those proteins separate themselves from the environment? And, you know, all these things that have to happen. Like we thought, you know, 60, 70 years ago that, you know, once we figured out you could shake up some like salty water at a certain temperature and make amino acids, oh, the rest of finding life was like trivial. But it turns out that like, it turns out getting from like that stage to actually life is really, really, really difficult. And, you know, how do these things assemble and separate themselves from the environment and then undergo some sort of respiration, or, you know, I guess I should say metabolism is probably what's key to life. You know, taking something from the environment and turning it into something useful is just a fascinating area of research to me. And I think if I could go back and do it all over again, I would probably do something in like biophysical areas, somehow crossed with like the emergence of life, because I just think that is just such a cool field, and maybe underappreciated and under talked about.
And underfunded. So when you're in DC, shout out to Original Life Research.
Right. Okay.
I'm particularly interested.
You're already a lobbyist now.
I'm particularly interested in the origin of chirality, right? So those of you that aren't familiar, like our DNA, our proteins, a lot of biological molecules are either left or right-handed, but they're not both. They're one or the other. In fact, all of living creatures have the same, I don't know, left-handed DNA, right? And that's some point along the line, life chose left or right-handed, and we don't know how or why that happened. It could have been random. It could have been chirality of photons coming from space, from a supernova. We literally have no idea why that 50% event swayed one way or the other. That's I love that question. I care about chiral molecules and light matter interactions, so that's my jam.
Yeah, really, really cool. Selective pressure.
That's fair. All right, we got 9 minutes left. Are you going to play any more? You beat Killer Instinct. I mean, what's left?
I know, I'm good. We beat Killer Instinct. We beat Mario Kart, Kirby's. I mean, we could play for the next 10 years and I probably won't beat it.
If you want to get
not why also talking on stream.
If you want to get really depressed, go watch a speedrun video of Kirby's Adventure and you'll watch somebody beat it in like 12 minutes and it'll just make you want to quit.
Well, I can go and practice now, and in silico, this will still count as a speedrun, right?
Yeah, if you have the right emulator, which you do, it does count.
Sweet. Well, that's how I'm going to spend the next 24 hours, so thanks.
I mean, yeah, it's like, not like you have anything else to do. Might as well game for a while.
Semester's over. We have the summers off. We're professors, right? That's how this works.
Yeah, exactly. We don't work at all. I didn't spend 8 hours today editing a paper. It was good, though. I miss editing papers. We had a lull because of COVID, just in terms of productivity and turning out stuff. Right. But now we're starting to ramp up again, so it's really satisfying.
Yeah, it is nice to get back to some sense of normalcy as far as that goes.
Selective pressure, but to a man with a hammer, everything is a nail. You are absolutely right. I use the same line, but my hammer is photons and every problem is a nail. Photochemistry solves everything. Ancient aliens chose it. I mean, but what chose do the ancient aliens not have chirality? I don't know. There's a guy in the 90s looking at a website documenting all the papers that people made left-handed DNA helices and figures. That's pretty fun. That is really fun.
Have you seen I think it's table of contents ROFL, top or something? Oh, it's the best. It's the best. It's
Can you
just
explain
all the
that
hilarious.
For our viewers?
Yeah, so TOC is table of contents image. When you like submit a paper, and I actually don't know how far this goes back. I 12 years, maybe 10 years, something like that.
Yeah,
generally when you submit a paper, you have to have like an abstract with an image in it, a table of contents image for like the printed journal. At least that's as long as I've been making them. And so these table of contents images should like summarize the paper. You flip through the journal, you read like the abstract, you see the image, it gives you some idea of the paper. But these table of contents images, some people are a little bit more loose with how they choose to like, represent their data and their manuscript. And so there's all sorts of hilarious ones, whether they're intended or just kind of like phallic by mistake in some instances, or just like overly cartoonish, or like a hand-drawn sketch instead of the actual data. It's quite hilarious. There's a Bob Ross one. So people get very creative, and for someone like me who's like an experimentalist, we don't have pretty pictures, so it's always just like a graph, and like that's it. Like I'm not going to spend like 2 weeks making some beautiful image. I'm just happy to publish the paper. So anyways, you can go to this site. I think it's TOS or TOCROFL.
I put a link in chat, and it's also running in the background of the stream right now.
Okay, you just scroll through, and it's just, they're so good. They're like, what? Why would you do that? Yeah.
Oh yeah, everything from hand-drawn garbage to nonsensical cartoons to... Oh, it's amazing. I think they're all chemistry-based. I had a colleague that ended up on this. True. I mean, some of the drawings are good, but yeah. Yeah, I showed it to him. He just laughed about it because, why take yourself too seriously like that?
Yeah.
What is that telling me about the paper we're viewing?
Fair.
It's like quadruplex one of them. But yeah, take a look. It's amazing. It goes through decades of it, actually. People submitting their own.
So good. Yeah,
just don't end up on that page. Be thoughtful in your TOC images.
Yeah, put some effort into it.
Yeah, exactly. All right, we got 5 minutes left. Any last-minute questions for Josh Melko? Dr. Josh Melko, expert in atmospheric chemistry, physical chemistry, pretty much any chemistry, as well as science policy. If you have any questions, throw them in chat right now. We are sufficiently drunk at this point. We will answer anything, so throw the questions in chat now.
Yeah, we definitely follow them on Twitter, Natty. The S-Posts science diagrams is pretty good. I think that's relatively new in the past year or so as well. That's a good Twitter follow.
S-Post, that's a TOC related or graph related?
Yeah, it's just diagrams from textbooks. I mean, I wasn't going to say the word, but the S stands for like.
Did you just censor yourself?
Yes,
we are an 18+ stream and YouTube channel. Feel free to swear accordingly.
I can't. It's I've coded this. Whenever I say a fucking swear word, it automatically bleeps me.
Still beeping. What is going on? Do you have that as that's a Stream Deck key, or what is that? That's awesome. Weather alert. Well done. All right. TTU Geography wants to know. Sometimes it seems like it ain't, but it really do. How come? It's probably second law of thermodynamics. I'm going to be honest. It's probably something to do with entropy is the answer. But Josh, you are still beeping. Are you intentionally beeping at this point? You broke your sensor. Technical difficulties back to haunt us. That is a perfect way to end the stream. This man is an educator. It's true. How are you running that sound? You have a second. You can't even talk to me right now, so we'll wait and see, I guess. Oh yeah, rage. That definitely deserves a rage. I'm gonna close
Should be
caption
back.
that. There you go.
Yeah.
What are you running that through? Like what
It's
software?
a voice mod. So voice mod is just lets you change your voice to be
any number of different voices or bleep yourself.
I think that's how it works.
Yeah.
So
That's awesome.
I use it a lot for classes just because it's another thing to try to mix it up and like try to be more engaging and keep the students from totally passing out.
So are you sad to go back to in person? I mean, did you like the online?
I think as far as teaching goes, I'm excited to go back in person. But as far as having more freedom and time with like family and being at home, like, you know, I just had a daughter not too long ago. So like that was really nice. So that part of it made it easier to spend more time with my wife and daughter. So like that part was nice. But as far as like the educational part, I mean, I'll keep some of the online stuff, obviously, office hours and review sessions and stuff, but nah, I mean, it's clear that the students aren't getting as much from the online environment as they were in person. And it's really hard to control for things like cheating, like in the online environment. So that's also a huge headache. You know, quality control kind of is tougher. So
I mean, thankfully you'll be back in a year and it should be back to normal. Like in the fall, we're in person again at FSU. There's no mandate for vaccines or masks. And I have an 8 a.m. class of 250 students. So
8 a.m.
Yep.
Dang.
Yeah. So science says you shouldn't have class for under 25-year-olds before like 10 o'clock. But who listens to science when teaching a science class? I'll just show up and teach.
Administrators.
Yeah, exactly. Yeah, time with the family was great, but yeah, it's definitely a cost benefit doing online classes.
Right.
All right, it's 11 o'clock. I think we'll call it quits there. Again, congratulations on both Killer Instinct and Super Mario Kart and Kirby's
Thank
Adventure
you.
next time. But also congratulations on the ACS, the Congressional Fellowship. I look forward to hearing your experience. It's going to be, no doubt, a very crazy year going ahead.
I'll be back on Ask a Scientist Gaming a year from now or so, and I'll share it with you.
Let's mark it on the calendar.
Right, great.
All right, everyone,
Thanks.
thank you for stopping by. Again, Ask a Scientist Gaming, it's a pleasure. The audience and their questions are what really makes this an awesome stream, so we really appreciate you guys stopping by and giving us your questions, and I love it. I learn something new every single time. Check our schedule. Our next one's going to be May 26th with Scott Stagg. He does cryo-electron microscopy to figure out protein structures. He's a biologist/biochemist, so yeah, swing by, prepare for your questions, and then every 2 weeks after that, we'll have a new science guest on. Josh, any parting words for the audience?
Thanks so much, and looking forward to your future streams.